to me, we're starting the ground school, and we're trying to make this official as it sounds, so that in the future, if anything goes wrong or whatever, we can pretty much say, this is the routine I do. My name is but it goes like so, pronunciation. I started in the beginning of 1980 or 81, and it was at that time pretty easy for me. It was easier to get a license back then, I think, than it is now. I don't think I could pass it or keep up with, all the rules and regulations now. I've just gone over 7,300 flights and probably somewhere around 600 hours all glider. And I have something over 4,000 ground launches, maybe 4,500, ballparking kind of thing there. And a few different gliders, different airports. I guess nothing earth-shaking other than pretty much survived over that period of time, and did it for a hobby. I did it commercially for a while, ride pilot and CFI for a job for a short time, fill-in kind of stuff. And I guess I would like to emphasize that I accept now, especially, I want to be telling you early, I know I'm not going to be your sharpest pilot in the hangar. But I do this now, probably, it kind of evolved, and because I'm lucky enough to end up with having the most time and experience at it, and so I ended up just getting involved with it, I guess, caught up in it. It kind of got to a point a number of years ago that we lived so much with a winch in our club, and I was around most often, and it got to the point of having to justify what I was doing, so I started writing the lesson plans and putting something together on paper to kind of standardize, and it just evolved. And then being involved with Roman at building the winches and going and demonstrating in different places in the country and things of that sort, it was like word of mouth started spreading, I guess, and we had to do a lot of checkouts, and I don't know, here we are, it just kind of happened by accident. And I don't know, any questions, I guess, briefly on, it's here, but that's all I do. It's a hobby. And we are, again, as I say, we are a club. We are the oldest club in the nation, incorporated in the spring of, I can't remember, 1930 or 31. And the club originally started with winching way back there, where the winch was the original winches was a barrage balloon winch from World War II that didn't get used, or maybe didn't go overseas, or whatever the heck they did with them, And it has been surviving under different modifications and trailers and axles and whatever else. And our old club winch right now is in Pennsylvania, being used by a group there, a guy named Steve something, I can't remember their last name now. And it was rebuilt by Roman, or us as a club actually, here in my side of my yard kind of thing, to use the new rope material and things of that sort. And Roman started, he came out with this one day, he says, I can build a better winch than that. And a few weeks later he had the drawings and prototypes ready for the dual drum diesel winch that is now operating in Canada, that we used for 3 or 4 years, or demonstrating and traveling around the country, or using it for ourselves kind of thing. And so I helped build those early winches. FAA says thou shalt have an endorsement. And so I mentioned that to somebody the other day, yesterday maybe, that All right, what are the endorsements you need as far as glider launching? You guys, I guess, know. Question you guys.
Ground, self, and arrow. Ground, self, and arrow.
Okay.
Yeah, ground, self-launch and arrow, so, endorsements.
Ground, self-launch, and air. Okay. Sounded like it was coming up short there. Wasn't your part of it.
Yeah.
Okay, yeah. So there are 3 endorsements. Now, at least, that you need whatever it is, an endorsement to do any of those launch methods. So
Oh, okay.
your air tow endorsed, you can't ground launch legally. Vice versa. See, like most of our club members right now don't know how to do an air tow.
If you don't have an airplane.
Mhm.
If you don't have an airplane.
Yep, so if any of our guys want to fly at somebody, some commercial operation or whatever, you know, technically, they're going to have to go through training to get an air tow endorsement. Like you guys that already have an air tow coming to trying to get a winch or whatever. Self-launch, that's so expensive. I've only ridden in a couple of them, you know, so I don't guess I'll ever see one, but and of course, ground launch. So, what I also want to emphasize is that as we do this, and I do your endorsements, that endorsement is either auto tow or air tow, or winch in our case, you know, it covers both of them. So I try to throw in their auto tow routines that sort of fit in too, that we can say at least, you know, you can go do them or whatever, it does cover you for that. Okay? Alrighty. Soaring Safety Foundation has been involved in quite a few things. They came to us a number of years ago, and other clubs, trying to gather information about ground launching. I think we are the most current or active ground launch group on the West Coast, I think. There's a group in Arizona out of Prescott that have lived with a winch and they ground launch all the time, I think exclusively. The Prescott Soaring Association or a club like that. So they, I think, are probably the closest group. Handouts, or I gave them to them, they asked for them, and they were going around to the other groups and asking for input also. So I think they ran out of motivation, probably. Okay, my disclaimer is that everything that's here was mine. I wrote it up, I put it together, I developed it or whatever. I've had little input since. And whatever mistakes and odd stuff, you know, that don't fit or I make, you know, and we're going in the wrong direction is nobody's fault but my own. It's like it is and was my program. So paragraph 1, item 1, winch versus auto tow. I want to emphasize with all the enthusiasm I can, the winch is strong, it's fast, and it's unforgiving, as far as I'm concerned. Okay? Not something to be taken casually. You can get to an air tow situation as a comparison, and you can be kind of behind and still get by fairly easy on an air tow because you've got a lot more time to look around or to react to something. With the ground launch and on a winch, it's like, in our case, you have about 47 seconds to get it all done correctly. In your case, with 3,000 or 4,000 feet, then, or 4,000 or 5,000 feet rather, then you'll have probably closer to 55, 65 seconds for a complete launch and you're done.
If we do a high tow.
Yeah, so for us it's around 47 seconds. Got a good breeze blowing, then it'll be a little longer, and if it's a calm day kind of thing, you know, it'll be a little less. But at any rate, versus the winch and an air tow, it's substantially different. As far as the winch and auto tow, which is on my paragraph here, I like to say that an auto tow, if you've done any of them yet, the kind of thing, to me, an auto tow is a really nice transition to a ground launch with a winch, because to me an auto tow is nothing but an air tow that just doesn't go as high. It's a gentle acceleration, usually a longer ground roll. The climb rate is, I don't know, you kind of feels like with an auto tow, you just gotta break ground and you just kind of sit there and wait until they run out of driving space. But the winch you gotta manage, the winch launch you gotta manage constantly, all the way. So if you have a chance to do auto tow someplace along the line, the concepts are pretty similar. It's just that it's, like I say, I emphasize it, really much closer to an air tow in time and climb rates. You know, kind of comfortable. Nice transition to a winch. The winch, as I told some of you guys the other day, as far as extremes are concerned, I've seen about half a tire rotation for a launch distance with a ground launch on a winch. To, depending on the glider, 150 feet maybe would be sort of long. On a nice upwind functioning day kind of thing, you know, here the wall is about normal. So if you're a wing runner, it's not like with an air tow, you see that guy running for quite a ways, it's, you know, here to the wall, and you know, you don't maybe take one step, and it's gone. So it's quick and it's positive. Any questions? Auto versus winch, or have you compared it to the arrow? Trigger any thoughts? Okay, item 2, paragraph 2, release hooks. I throw these in here and just because there are some new people, so again, I'm going through my routine. You should all know what a nose hook is. Sometimes it's in the air intake for the pitot or air scoop or whatever. Sometimes it's a little bit behind the nose kind of thing, but still considered a nose hook. Ours are, or this one we're using is back, I don't know, 28, 30 inches from the nose per se, on the bottom of the fuselage. That's nose hook. So then the next type of glider hookup, what we call a chin hook. The 233 is obvious for that sort of thing, but something backed by the front seat pilot possibly, you know, is what they call the chin hook on a 233, which is substantially improved over the nose hook. But a 233 you can ground launch on the nose hook. Don't have any porpoising per se, but you definitely don't climb like you will. That chin hook really is substantial if you ever work with a 33. Very nice. Nice compromise. Then you get back to the CG hook, which is some air tows. I guess some gliders got to do, you know, these European gliders, they don't have a nose hook. You'd launch on an air tow with a CG hook. My understanding is some of the CG hooks are inside the gear well. Ours are right in front of the gear. You know? But the whole concept is that for ground launching, those are the better positions, designed for that to work well. Grobes have a disadvantage because the CG hook is in front of the wheel. And so that means when you do your launch, the rope and harness assembly, you're running over it with the nose wheel. So you're either cutting the tire or you're burning through whatever you got under the tire kind of thing. So you have to be careful on the launch and how you set it up, because that CG hook is in line with the nose hook center of the fuselage. On Polish gliders at least, and I'm sure there must be others, it's offset to the side. So on the one we're using now, it's on the starboard side.
Yeah, the
Offset.
Schleicher's on the side.
I see my label is off to the side.
Okay, so the convenience of that is you're not running over it with a nose wheel, cutting your tire or burning the road. Okay. The other thing you do is when you set it up on the runway, like on ours when you use it, depending on where they happen to end up, generally if you put the nose off to the port or left, 3, 4, 5 degrees, just a little bit,
Into the
you
wind.
automatically already improve on that because it's offset to that side a little bit. It'll never have an issue with it. With a Grove, you'd have to do that for sure, really. So, okay, 2D, there's the shoulder. Probably, I don't think you're ever going to see any more of them. The only one I know of for sure is the L13s, Blonics. They were, I mean, the most true CG hook of any of them kind of thing. I mean, physically on the aerodynamic CG probably, or really right at that, within an inch or two. Sitting under the back shoulders or rib cage of the back seat pilot, essentially, a bridle system coming up together to a single line in the front, and back release mechanism, everything right on the what I call the shoulder, pilot shoulder. Okay, but I think, you know, that's gone now. I don't know if anybody ever do anything like that, or if there's another one. Do you know if there's another one besides Blonde
I've never even heard of it
that
before.
have the shoulders?
That's the first time I've heard of it.
Yeah. Most of the newer L23s have gone to the tossed
Yeah.
system, I guess, so it's really hard to beat the tossed hook. Yeah, that's a wonderful design.
And the L13s don't fly anymore, so.
Yeah, but at any rate, that was common when I wrote this, and so I leave it in here just to tell you that it did exist. Maybe, I don't know if anything else around actually uses them, but hook up here. So you have the nose hook, something aft, chin hook, which compromises between nose and CG, something for CG in the shoulder. Okay. Any questions on or comments on the toe hooks, release hooks? Okay, ring types.
This one, right?
Yeah.
In my experience, by the way, item A there, it's not the stuff you eat. You notice there, TOST is what it's supposed to be. I am only aware of the two types of rings, Schweitzer and tossed. Okay. Anybody not see both? Do I need to get one out and show you? I mean, yeah. I assume you guys have all been around that stuff enough. You don't need to look at it. Okay.
Know the difference.
Okay. Drogue and parachute, leader lines. Primary purpose of having a parachute on there is to keep tension on the rope and give the winch driver some place or some control over where it ends up, because you actually fly that parachute hopefully back to the winch. Without a parachute, or if you get somebody someplace where once in a while they put the parachute on backwards and it doesn't open, it comes down really pretty quick kind of thing. And it doesn't give the winch driver a chance to control where it goes. Leader, probably there's not much of a limit on what you can put on one for a leader. I will say that we use what I call a leader, like in fishing. We have probably a 5/8 inch rope that's hooked to the glider, or real close to it. Then in front of that, we put the weak link. All right, we have a tow string. We have actually a piece of winch launch rope next to under the nose of the glider. In front of the glider, we have a carabiner, and then we have the heavy braided rope. Huge one. Then there's another carabiner, and then the weak link, and then parachute on the launch line. And this whole thing, 60 feet long in our case, maybe 50 or something of that sort. We developed and got to this because actually in Arizona, Estrella, and places like that, El Tiro, running with a PW5 or whatever it is in the growth kind of thing, we had a parachute that was further forward. We had a weak link that was up here next to the glider, where it's kind of traditionally when you have them in most places. And what we found was that, boy, we were getting rock blasted unbelievably on launch kind of thing. That short drag time, this is picking up rocks and crap and peppering the canopy and the wings and all kinds of stuff. So, boy, we stretched that out there to protect the glider. Then the next thing that came along, one of the other clubs got me started on this kind of thing, because we had a weak link here, in a traditional place. Well, if you break a weak link, and most training is, everybody breaks a weak link, first thing they do, they want to pull the release, and they just throw away a $50 set of rings out there in the brush someplace that you almost never find back. We've got 3 or 4 nice rings out there along the runway now, you know. Yeah,
Get a
well,
metal detector.
yeah, well, so then one of the other clubs, Orange County, was experiencing this and got us started on it with a combination of rock protection and not wanting to lose rings all the time. So now we have a solid rope set up to the glider. Then the weak link is out here in front. So when you break the weak link, you have this 20, 25 foot or whatever, I don't know what it is that we've got on there. Nice big rope. The brighter the color you can get it to whoever pulls it kind of thing, or it might be able to see where somebody on the ground where it drops or whatever, but you got this, at least this pile of this rope, and it usually goes into a pile, by the way. It's not necessarily laid out nice and easy. But anyway, you have this substantial, heavy material to find those expensive ropes back. And it doesn't change anything, it seems like, to have the weak link forward. And all this goes with the winch, and this goes into the pile of the brush. Done, deal, hopefully. Find it back most of the time. With a nice good toast back releasing. You all know what a back releasing is. If you're airtow, you don't experience it.
No.
But you know what a back release is?
No. Mm-hmm. Oh, back release, yeah.
On a ground launch, you got to have if you do it on a glider, you got to have a back release mechanism. I mean, it's your life probably, or it's dependent upon that kind of thing. Which simply means that if this breaks here in our case with the toss hook mechanism, it's such a wonderful thing. There's enough wind and drag probably on just this piece of rope here to actually disconnect it from the glider without you having to do anything most of the time. Schweitzers, no. But I got another paragraph to cover that sort of thing, and I'll try to demonstrate it if you're not familiar with it. I think that's it on this leader and hookup kind of stuff and why it's so long. Any questions? That paragraph? Okay. Next, paragraph 5, cable inspections. This is left over from the time that it really was cable. Meaning steel cable. And a short place like at Torrey Pines kind of thing is where this was developed from. Every day, part of the pre-ops kind of thing is somebody walks and looks at the cable. You look for the frays, you look for the damage, you look for the kinks and everything at the beginning of the day kind of thing. We never do that with the ropes. Set it up and go. because it's too long and you can't really tell if it's gonna break someplace unless you've caught it on, you know you've caught it someplace, then you better go look at it. If you've tangled it on something kind of thing. But at any rate, there's really, in our case now with the synthetic ropes, there's no pre-day operation of checking the rope. But if you got the steel stuff, kinks and splices and all that is important.
When the weak link breaks, do you ever get cable knots? I mean, rope knots?
Backlash?
Yeah,
No.
because of the rope.
Well, parachute,
Yeah.
rope, yeah. Okay, those of you who haven't seen it, this is a piece of winch material that used to exist.
That is
We
nasty.
used to get thousands of, we used to get thousands of feet of that stuff because it was a Navy tow target cable.
I'm sure it's a
And I don't know where other people get it.
And when these broke, it was really spectacular.
Well, and the other thing is that 2,000, 2,500 feet of that is gross in the glider. It can't climb any more than that. Really dangerous stuff. And when it breaks, it backlashes, or when it falls, well, you can see how all the kinks in it. If we were still using this kind of thing, each of these little humps like this was a wear spot to where it would be grinding it apart kind of thing. If this one has any on it, I can show you. But there's this outer sheath. Yeah, there's a piece.
Yeah.
In our case with
Looks like a
33s and things
breakable.
like that, we would go, about 50% of these strands would still carry the launch if these strands are broken kind of thing. But again, nasty stuff, plus being heavy. I like to now emphasize that you guys heard me the other day. I think when they came out with this synthetic rope, that was the revolution for ground launching. I mean, from then on, we started making progress, getting away from this stuff. Now, there is another kind. There's this single strand piano wire type material. The Prescott group live with that. They like that. They've got a system developed. They use that all the time. But I understand it takes 4 to 6 people every time they break that to put all that and splice it back together with it and do the next launch. It's a big deal.
Splice.
Wouldn't let us fly.
Yeah. Okay, now those of you who haven't seen it before, this is the revolution. This is what we use. That technically is supposed to be 3/16, but it's kind of feathered out somewhat. I'll start on your side. There's the beginning of a splice to give you an idea of what they look like.
It's more costly.
Don't pull it apart because I don't have the
Okay.
fed here.
Sorry.
It's about 50 cents a foot.
How much was the one that we were using for 10 cents?
Let's see, we're paying,
Slice.
as our,
Which again, I can't remember, but I think 5,000 feet of that with the spool is about 55 pounds.
Can't make too many.
With a steel cable, 2,500 feet, you pretty much needed a forklift.
yeah,
This was, we were doing, I think with Roman, it was 4,500 roughly, depending on whose brand you got and that sort of, about 4,500 working strength when it's new. Okay, so as far as, again, if you're working with steel, don't, if you can. If you're working with that rope, we don't do anything. We just set it up and go. Okay. one of my sidebar notes here is that dealing with the weak links and things, you obviously got to have work with this stuff with the weak link. Some people have taken to save the rings, if you know if they break a weak link, a setup is to put ribbons on the ring. You know, they could tie a ribbon around it. We used to put those like remove before flight kind of streamers on there, whatever, to try and find these back. It was one of the things that was done at one time. As far as the ropes are concerned, when you're out here, our field kind of thing, avoid driving the vehicle over the rope. Not probably going to ruin it, but I want to kind of like reduce the chance that you run it over a sharp rock just in case it does something. But that stuff is really, really difficult to cut. You need a really good blade to cut through this, or you know. So if you drive over it by mistake, it's no big disaster. But at any rate, my routine is that okay, try to know the ropes there. If you go out to get the glider to retrieve it, you know, stay on your side and take the glider over the rope. Just, I don't know, might help. Long run kind of thing. Test question. In air tows, they tell you about a knot in the rope, what that does to rope strength. And test question wise, I don't know. What's it do to what do they say that knot's going to do to the rope?
It's a straight about half.
You comfortable in remembering that? It's pretty true. Because when I was working with Roman kind of thing, we had pull tests and you know, sit on a big post and we'd be cranking on it with a big come along kind of thing, and by golly, it's not far from 50%, you know. There's some variations, I guess, so kind of keep that in mind. Don't let any knots get in there. But it's very difficult to get knots in this too, because when the rope breaks, it ends up on a pile someplace, you know. It usually is just, it's just great stuff. That's why I keep saying, I think this is the revolution in ground launching, right? This stuff. Okay, so what did you say air tow weak link strength reference was? You guys shouldn't have any questions about it. You shouldn't either, I guess.
It's 8120. 8120, isn't it?
8,200.
8200, yeah, 200.
80% to 200% of the gross weight of the
gross
glider.
weight.
Right.
Of the glider.
Chuck, you familiar? Remember that? Okay.
No, I don't.
80%.
I give them the test questions. I'll tell you now.
120 for 'em, yeah, 8200.
I just, use the rest.
All right. If you're doing a ground launch, is it the same standard? You should know. I'm going to avoid you on a lot of stuff. You're a little more current. Is it on a ground launch?
For
I don't know. Is it different on that?
It's different. FAA wise in the manual. So you got 80 to 200%, which you guys are used to seeing. It's supposed to be what you're working with. 25% more at the tow plane if you got one at each end kind of thing. On a ground launch, it's 100 to 200%
Oh, so it's stronger.
for a weak link for ground launching.
So 80 to 200
Gross weight.
gross glider weight
Is
for
aero tow.
aero tow, 100 to 200 ground launch.
Yeah.
Okay.
Now, I'll emphasize that we've tried to get close to that, but usually the weak link wears and we use it until it breaks, and so I don't know what the hell it really is. But anyway, you got test questions with it, and it's, academic, that's supposed to know that stuff.
So if you're launching a sparrowhawk,
Mm-hmm.
and it's super light thing, you have to have a really weak link.
You want a weak link that probably propylene for something like that for 126s or whatever. And if you're going to some operation somewhere, that's something I'd really, suggest you kind of know versus, yeah, you go get something, the guy comes walking up there with some weak links like this, and you got a 400-pound glider or whatever, a 126, and technically you ought to, be concerned about it versus seeing, okay, you got, or keep your own weak links for your plane, and then kind of like you're under control with that sort of stuff, but at any rate, there's a difference. You get up there with a DG 10,000 or whatever it is, the thing weighs 2,000 pounds or whatever the hell they are, it's like, yeah, you better
Yeah,
be aware of
the
it.
25 weighs 1,700 pounds, so we have a really heavy duty weak link.
Okay. All right, so again, ground launch, 100, 200% of the weak link of the gross weight, air tows. Most of you should be familiar with on the 80-200. Okay, my next paragraph 5E is sun fade. If you're using this polypropylene stuff, around here it happens fairly easily, but you can see that has a pretty good yellow color left in it yet. That's not very old. Probably going to be closer to the published working strength kind of thing. You take one that's that color, and you see that hooked up to your glider, you can kind of, well, okay, it's definitely a weak link.
The whole rope is a weak link.
Just be conscious of it. Something to help you with, at least if you remember how it looks in that regard, that kind of stuff. Okay, there's the 5F. I guess we've already covered that. I didn't realize my notes here, so real close if you got a knot in it to 50%. Now actually we have, I don't know if we've taken it out or not. It is, paragraph 6. Very valuable issue is the release mechanism, back release especially. Are you all familiar with a Schweitzer hook setup? No? Okay. Well, I need one note. Schweitzer uses something something on that order. This is the fuselage coming along here, everything pretty much like this. And this is the American-made release hook mechanism. You take that larger round ring.
Maybe it's almost
No, I'm familiar with the hook.
This ring is connected on this hook mechanism this way. This device here moves which is the locking mechanism, so that during the launch, either on an air tow, it's in a pretty much straight ahead kind of thing, comfortably notched into here. On a ground launch or an auto tow, it's something like this, but it's up into here. And the problem that happens with this release mechanism, two things that I'm aware of. There's a step here, and there was an AD at one time or whatever, or still I guess it's practicality-wise, this step is supposed to be filed and kept smooth. If there's a little bit of wear or burr on this step, this lock mechanism gets, the higher and harder you pull, the tighter this gets. And if there's a little bit of a burr or anything on there, you cannot release it. Happens with a tow plane too, by the way.
Yeah, it's the same hook.
Except
as a
Tow planes usually.
It's upside down on a tow plane. I don't know why they ever did that, but
That's because the worst is to be, you want to be able to release pulling up because
Pulling
that's
up.
pulling the nose
But it
down.
You
doesn't.
don't wanna pull the nose down.
you can't, if it's really in a serious situation, you can't pull hard enough to pull it off probably, in most cases. But
Yeah, they're bad hooks.
that's in theory. To me, it's on upside down on a tow plane. They mount them upside down. But at any rate, on the glider, that's the theory. And if you get the rope and ring mechanism all the way back here, where the rope stuff is, then theoretically this is supposed to what's called back release. It pulls this off of here, and this hook swings off, dumps the rope kind of thing. On a ground launch or a winch launch, I'll guarantee you it ain't going to work. Technically, it's there. It is a back release system. It does back release, but it ain't going to do it when you really need it. Because generally speaking, when you're in trouble with, say, a Schweitzer kind of thing, boy, something from vertical to darn near vertical is where the rope is kind of thing, on the tension on it. You're never really overflying it where you're pulling it backwards. I've seen two hands and still not get it to come off. The only reason it comes off if you use both hands is because you let go of the stick and you pitch over like mad because it's pulling you down. Maybe your release is going to be. But back releasing, that's the term. You need a back release. Now, if you take the toss system, I can't draw that to make sense out of it kind of thing. Slick as a whistle, foolproof, I would say, and works every time. All you need is some drag on it. Doesn't take much. It just click and that puppy is off. It's wonderful. If you get too high on the launch, it's coming off. Whether you release it or the winch driver helps you or whatever the kind of thing. With that toss system, superb mechanism. But not on a Schweitzer, even though it's technically it's a back release
There's a
mechanism.
couple incidents.
Okay, so back release means when the rope is going back, should come off. You want it off. Any comments?
What's the basket that you were talking about when you talked about the redneck ring?
Oh,
It's the basket that the round other ring goes into that triggers that.
That's the
Back
release
release,
mechanism.
yeah, the whole,
The whole,
that round basket that the hook
it
is in
pivots
there,
and
yeah,
unlocks it.
comes back,
yeah,
yeah.
yeah,
That's
I call
the key
it
of
a
that.
nest. I don't know what
Yeah.
else it could be. They've got, I'm sure it's some technical name. But this does notch, or to me, nest in this
Yeah.
part of the hook mechanism so that this ring receiving some angle from here, which is around 70 degrees ballparking. I'm sure there's a specific number for it, but that puppy's off.
Yeah.
It's out of your way. You're done with it. But all right, 6E, the guillotine for release mechanisms. You definitely should avoid riding on a winch that doesn't have an operating guillotine on it. And the term guillotine is some kind of pneumatic, mechanical, hydraulic device to cut that rope at the winch, just in case something goes wrong, kind of thing. I'll say that, and emphasize that this stuff, the new material, it needs a good mechanical something device to cut it. You can't run out there with bolt cutters like we used to keep bolt cutters on the ground in case somebody with a theory they could cut, or a hatchet to hit the roller with it or something with that steel cable. None of that stuff would work with this. And when you use or find out with this stuff, again, as I've mentioned before, boy, unless you have a really good sharp razor knife of some kind, you're going to work to cut through this stuff. Okay? Roman uses a guillotine. By the way, I claim that the guillotine is my concept on the winches. He was here one day saying, "Oh, I gotta put," and I don't know why it came to me, but the thought of, these nail guns for setting nails, gun cartridge into concrete kind of thing. I have one, and I don't know, for some reason I said, "Oh, well, I ain't gonna." Well, about 4 days later, he comes back with his manufactured breech and a firing pin and a piston kind of thing. So he's got a Rockwell, I don't know, 40 or 60 knife blade setting up against an aluminum block that the rope goes by with a pneumatic firing pin on the lowest charge of a nail gun cartridge, a 22 nail gun blank cartridge kind of thing for the nail gun. And that does it really well. You could loan your glider out, or you got something at the club or whatever, that guy should be endorsed, or better be, because hopefully he's done some training. And the other, of course, FAA and insurance comes along, "Oh, not endorsed to ground launch?" Your glider. I don't know what other liabilities come in with it. So personnel-wise, again, I want to emphasize, you don't want to fart with a ground launch without having an endorsement and that training in there. It is, on a winch, again, it's very unforgiving. On an auto, probably not going to bother you. Okay, 7B, winch driver. Again, it's nice to know who's pulling you. Gives you a definite heads up. Winch driver can make a big difference, really big difference. I mean, versus, obviously breaking the glider quicker or not kind of thing, because they really can influence you tremendously. So again, knowing who's driving you from the winch is valuable to you. Signaler, 7C. This is a holdover from a short runway like at Torrey Pines. I think we probably had 800 feet from the winch to the launch line, if I remember correctly, kind of thing. So whoever's driving the winch actually was watching a flag person, because the glider was out of sight of the winch driver. Definitely contoured kind of thing. So we had a signal person, which, again, anybody can do it or wants to. We used flags. The guy would be on the hump in the high spot off to the side, away from the glider, 150 feet or more. And when the pilot PIC was ready to go, he talked to the signal person, and the signal person took over the launch. And you don't need what the routine is, because you have to develop your own, but checking for traffic, looking to see, that kind of stuff, and open. But then you would use the flags. Do you have any idea, any of you know what the flag signals are, if you do flags as a launch, if you ever were into, or paddles?
Isn't it the same as the hand signals?
Okay, he's questioning.
Circular for go, and this is take up slack.
Well, let's ask, because you guys are probably going to be the ones that working the hardest on knowing these. It's a test question.
Aerotow type
Okay.
signals also.
So what are the signals for air tows, or at least name one?
No knowledge.
That's
Name one?
Waggle the rudder to go.
the
Okay, that would be one, but that's not a
take
flag.
up, take up slack, and then a full circle for it to go.
Any input? Okay, well, just for the sake of academics, just so I can say I've covered it kind of thing, it's the same as the air tow signals.
Okay.
And for Chuck, same thing on the flight lines kind of thing. Moving your hands, in this case from a distance, it's got to be a flag or a paddle, across your knees, just take out the slack. Yeah. But if you're 800 feet away,
Yeah.
you want something bigger than that.
And probably more colorful.
Yeah, but the concept's the same, yeah. With an air tow kind of thing, yeah, you're only 200 feet away, it's easy to see kind of thing. One of the precautions with that, if you got somebody doing that sort of thing on flag signals, you want to move it briskly, across your knees so the flag trails, because usually you got a little bit of wind to some degree. So if you go nice and slow, the flag is like this across your knees or whatever, well,
Can't see.
no, not, so you gotta go fast enough to make the flag trail, or of course the paddle. But then what you gotta be careful with is that you don't come up midpoint kind of thing, because if you're looking at it from 800,000 feet away kind of thing, which is hard to see, winch driver can't tell, okay, he's going up, nope, he ain't, and he's back again, is he going all the way, nope, you know, so you want to be brisk down here at the bottom, take out the slack. Then you want, as the flag person, if you're the signaler kind of thing, you want to be watching the glider. And you don't want to tell them to go with full power until the tension is on and the glider's starting to move. It's not one of those water ski things, you know, you get 6 feet of slack in there and hit it, you know. You don't do that. You want the tension, you want the glider to move, then you come all the way over, which is full power. From then on, the winch driver's not going to be looking at you, he's going to be probably watching the plane. Okay, so it's very definite. Again, brisk enough to make the flag trail. Or of course if you got paddles, that's great. What if you got a problem? Somebody walked out there at the last minute and gets in your way. How would you stop it?
Yeah.
You only got one flag,
Back and forth on time.
straight up.
All straight up.
Straight up.
So same as the stop hand signal.
Yep. So it's not doing this anymore, but the problem with that is now the flag is trailing if you got a nice headwind kind of thing. You, not guaranteed kind of thing, but at least he's not seeing this anymore.
Radio.
Radio's the very best. Absolutely. Radio in the plane, and you as PIC, you're talking to that winch driver directly, and there's nobody trying to interpret for you. And then I'll throw in there with the radios, in case so I don't forget it later on. You having anybody else on the field kind of thing, especially in ground launching, anything at all goes wrong, you start yelling aboard before they take off. Many times as a take, winch driver hears it, he stops or whatever, glider, pilot PIC, he pulls the release, get off, stop the launch kind of thing. You probably don't want to be yelling aboard when he's already climbing, like there was an air tow accident like that not so long ago. Somebody was, I guess the spoilers were open. Somebody in the ground mistakenly, whatever, was trying to help and said, abort, abort. Oh, shit. Pulls the release with the spoilers open, and of course they went into the trees kind of thing. So there's a little discretion there kind of thing. If you're anywhere on the ground or being in a launch, stop the launch. Anybody stop the launch if something got missed. For one example I had, I couldn't stop the launch. Carabiners, I don't know if I've got one like it here. You can invent some other systems, but you can see that quite well. And we've done that out on the dry lake kind of thing. But again, what happens with the radio, by the way, is if you're a mile away, the ground effect is a lot of times the radio doesn't work. You can't get to them. So what we have done is I have out here in a pile, I have a PVC pole with some guide wires on it, and we'd run a antenna up 15, 18 feet kind of thing. And so to get the launch going, and we did this in Arizona, El Tiro kind of thing is where we used it the most. The guy that was doing the launch control would walk over to that pole, connect his handheld, contact the winch, and take out slack. Glider would start, go, go, go. And we'd do the launch. But he'd get through to the winch with the pole up higher, but the glider wouldn't. Now, as soon as it broke ground with the glider, good trick. Line of sight with the winch. Okay, so there are at least that limit with the radio. I'll try to remember that. Okay, 7D, wing runner. Got a little blank spot there. This one always brings out an interesting, I think, discussion. if you were the wing runner on a ground launch, even an auto tow, do you think it makes any difference whether you go upwind or downwind side if there's a crosswind? So before you blurt it out, think about it a moment. What would your choice be? Would you think up or downwind side of it? Would it make any difference? It's three choices, A, B, C.
So you have more control.
Okay, let me check that since you're thinking about it now. Say the wind's from Craig.
The wind is what?
Wind is from Craig, crosswind.
Okay.
Okay, we're launching
Academic.
this way.
Okay?
Huh.
We're going away from where you are now. Good point.
And the wind is on
Okay?
Craig's side.
Coming from Craig. Rudder sitting out here, Chuck. Upwind or downwind side?
This is the downwind side and he's the upwind side?
Yes.
Oh, I picked the upwind side.
And you said downwind side?
Downwind.
All right, well, the academic question, answer them after is downwind side. We'll give you as the wing runner
Chance to keep.
here right away, which I started to screw up.
It scares me.
Yeah, you got this kind of weather vaning stuff here. Now, if you're on the upwind side, which is what I was screwing up here, you've got the thrust, now you've got the wing weather vaning aft. Now here's where you got to run like a rabbit because the glider's going to try and turn this way. You're going to have to add not only the weather vaning to your run, plus the thrust, whatever the acceleration is, to go fast enough to turn that thing back and keep it going where you want it to go. Now the opposite, which is where I screwed up my logic here, is that if you got that happening over here, it's much easier, you can hold back, you can get a lot of control over bringing that thing and keeping it on the runway or your line that you want. I profess one exception. If you have a bunch of obstructions not very far away that you got to be careful of or something of that sort, then it's maybe a consideration to be on the opposite side of the obstructions because again, if all the obstructions are right over there, again, you can jerk that plane back away from the obstructions a lot better than you can be over here running like a rabbit trying to keep it from going over here toward the obstructions. So downwind side will give you an advantage if you're a wing runner. Okay? Test question. All right, so in your blank spot there, wing number 4 or 7D, yeah, the opposite, downwind side or opposite the obstructions. I'm not sure what's in your handout now. I know I've altered it. Yeah, you got 2 blanks. Okay, good arguments, thanks. I was having a little trouble getting that straight there for a bit. Item E, safety checker. Personally, I consider that the wing runner. When you go through these stages at our site and our routine, when you're doing the hookup and wing runner, I'm asking you to be the safety checker per se. To me, you're the last person with your hand on that plane. You're checking traffic, checking ground traffic or obstructions, and it's really nice. See that the spoilers are closed, the canopy's latched. In our case, the canopy latches both go the same direction. You can look through it and see if they're both, remember they're both at the same angle. The emergency jettison on the right side and the regular routine opening, closing on the left. Both of them go and lay in the same direction. So if you're in a wing runner, you can look through there and see they're both the same way. Or I've been to an airport where they had one specific person that had nothing to do but to walk up to that cockpit and say, hey, you got the spoilers locked? Okay, you got the canopy locked? Yeah. And he walks away. That's the point. I do know that there are some operations that get all this set up and they come back with a tension or slack out a rope and they stop and whatever they do and then they go through this other motion to start again.
That's a double.
To me that's just one more step in the way probably. I've never actually lived with that, we've never done anything like that. But if that's what you're talking about, yeah, once you start to launch, it's fixing on the spoilers, so. I'll just throw in there site-specific, you might be in an operation where that works for them. I personally don't think it's not what I teach, at least. Okay, back on safety checker. You're the last, if you're doing the hookup routine, you're the last person with your hand on the glider, and you're also the person who's hooking up the rope in the harness assembly. So when you get asked, ready for hookup, that's a common term we usually use, ready for hookup. And if you're the guy doing that cycle kind of thing, two ways you could do it. You could go in there and just use the back release and hook it up yourself if you want to get one step ahead kind of thing. There are those who say that nobody should be hooked up to anything until a pilot's ready for you to hook up, so site specific. A lot of times with our own guys, they're inside. I'll go ahead and hook it up, me personally, if I'm on the line, but I specifically, you are hooked up, anything goes wrong, just pull the release right now, but again, that's what I do or sometimes do. But as far as a drill is concerned, if you're the line person, wing runner, you do the hookup whenever it's asked, ready for hookup, or told ready for hookup, you do the hookup, is the step drill. Then you walk, I erased it a while ago, but you walk all the harness assembly out to the rope, tow rope kind of thing, straight out in front of the glider and give it a little tug. It doesn't matter what the rope from the glider so much. Some guys make an effort to go and lay it out, and here's the parachute and all this stuff. They'll make sure this isn't in a knot or something over here, which never seems to be, but just not as long as it's tangled. Here's the parachute and all the leader assembly going to the glider. So pull it out there, lay it out straight, give it a little tug. Then you walk it back, because there's, I don't know, I can't remember, 4 carabiners on there or something of that sort. So you look at each carabiner. Two things offhand, we take, twist the loop, double it kind of thing, and this goes on the carabiner. Just popped it off. And it looks a lot like that to start with, okay? If you're walking back and if you see that, you want to fix it,
Threads.
okay? You want to avoid that. Now, it only takes a couple of launches and this thing takes a set and tightens on that sort of thing, but see, this piece hasn't been used that way. Now, what you want to do is you want tension on the rope and you want it to lie with a smooth loop. And again, you're the wing runner, line person kind of thing. As you walk back, you look at each of these carabiners and try to have it like that. Now, most of them will be snug already, okay, but you double check it. You want to make sure the carabiner is closed. If it's one of those spring latch ones or one of these screw-on ones, somebody did something or didn't fin, you want to make sure it's there, because it'll straighten out that carabiner.
What's this bit?
Okay? When you lay it out, you want to straight pull all the way through. That's what I'm asking for at least. All the way up to the glider, any carabiner. And as you walk back, you kind of double check, make sure there is a weak link in it. Our weak links, you'll see, are really kind of weird. But you want to make sure the weak link is there. You want to look at the wear points, usually is about here. This is where it often will break, because it's fraying or rubbed the ground for a while and this kind of thing. So you kind of glance at that and kind of like get to learn that, well, yeah, that's still okay, or not kind of thing, okay? And all the way up to the glider. The other thing is I like and got started with is I want it laid out, because you get that chance to take these kinks and stuff out of it and check the carabiners are locked. But if somebody just brings up a pile of parachute and leader and leaves it in a pile over here to the front, And now the winch is starting to take slack out and the parachute's bungling and rolling and twisting and trying to pull all this stuff out straight. It ain't the same as you comfortably and giving a little tug. Just the drill with the tug. Okay? Wing runner, wine person. Again, you're the last person with your hand on the plane. Spoilers, canopy, traffic, leader. The rest is up to the pilot. PIC. Okay? Tail runner, 7F. So what's been your, well, it's been a while, I guess, if you, especially in a 233 something when you're sitting on a skid, if your tow plane accelerates too hard, what usually happens?
Slams down.
Swings the tail, bangs it. Well, on a ground launch or an auto tow, that's much more severe than what any air tow probably would be. You can break something. So, on
Your
a,
loop's back.
thank you. On a launch, on a ground launch, with a skid operated glider to where it's sitting down on the skid, you will call as PIC wing and tail. That was our standard call. Somebody goes back and flat hands and pushes the tail down on the ground. You as the pilot, and the wing comes up, of course, for like any launch kind of thing. And you as a pilot, you on a 233s, a lot of times, practically, depending on how heavy the front person is, I'm thinking, it's darn near full back stick. Keep the tail down. 233 is a wonderful ground launch glider. It's excellent. I mean, like, when you're set to go, it's in takeoff position, and all you got to do is move. With the Groves nose wheel kind of stuff, you know, lots of pilot weight on the nose. You got to go some distance before you get elevator authority. So you got to go through this transition zone. You're sitting here rolling on the nose, and it takes enough forward motion, and you get some elevator and amount in there, and it well with a winch that happens so quick. You need to stick in the right position, which is real close to center, and it's going to vary with front seat weight, somewhat kind of thing. It's going to come off quick, and it's going to be going, and you got to be ready for it. And usually presetting the stick in what is your approximate takeoff position is very valuable. You don't want to do like, I'm asking you not to do like a lot of air tow guys might be used to. You can sit there kind of casually, stick can be out of, up there against the stop, and okay, well, I guess I'll start doing something, but here you've gone 200-300 feet down the runway or whatever kind of slowly. That'll cause you some problems with the ground launch. Remember, the shortest takeoff roll I've said is about half a tire rotation. And you're climbing. Stick isn't in the right position, boy, you're hunting for something, and that hunting could get you in trouble. Okay. So at any rate, tail runner is a term, and it does, if you're working with a 233, you need a tail runner. That includes an auto tow. Okay, 7G, an observer. We no longer use an observer, but when we were at Warner Springs and Torrey Pines, where there's a lot of strange traffic and stuff like that, it was one of the stations we have is somebody extra down at the winch that when the launch sequence started, that person was, where the winch driver doesn't have full vision of that stuff. A place like Sky Sailing at Warner Springs, I asked everybody and tried very hard that whoever the observer was or the winch driver on that air tow that took off over here on the parallel runway, that they're far enough away that they're not going to do a simulated rope break practice or a real one, and here you go with a launch or something and they've got hit 200 feet and they're trying to come back and you've got a launch going. Watch for that kind of stuff. If you got a dual operation going, make sure that air tow is Yep, they're too far away, they're not gonna break the rope or get back by the time we're gone, you know, and the observer can watch for stuff like that. Or the observer might be aware of looking at the level, and here comes this guy squeaking straight in, and he's just gonna make it kind of thing, he's down here at the bottom. Winch driver goes and looks around, you know, and this observer maybe catches this guy coming from something along the back, in the back. You know. Whether you have one or not, that's site-specific kind of thing. Torrey Pines, when we used to live there, we had hang gliders, paragliders, and RCs, and we had a launch window, and it was a big deal to have somebody back there, and we had horns and lights, you know, and all that kind of stuff along with it. A lot of site-specific stuff. Okay, that takes care of paragraph 7. I have on the sidebar here as a reminder now with the launcher setup. You got a rope truck or a golf cart bringing back all this hardware for the next launch. I'll throw that in here now. If you are a rope truck retrieve driver kind of thing, well, if you are the rope truck, what you should do, hopefully over the weekend, one of the things you want to remember, as you start bringing the rope from the winch, accelerate slowly to get the rope going. We drive back really slow, like probably no more than about 10, 15 mile an hour. My only reason for starting to do that is that rope is dragging through gravel all the way back kind of thing. And I kind of got to thinking about bench grinders or die grinders. You know, the faster that thing goes, the better it cuts. You know, you're grinding steel. And I thought, well, maybe that's doing the same thing to that rope. So usually there's plenty of time, 10, 15 mile an hour. If you're in a grass place like the Canadians where they had 7,000 foot of grass in there, they're driving 50, 60 mile an hour back on the grass, and you know, it's not giving them any trouble. Okay? So this is if you're a rope retrieval person. Accelerate away from the winch, make sure the slack's out of it gently, start the drum moving and accelerate to whatever speed. In our case, not much, 10, 15 mile an hour. I used to go back 30 mile, 35 mile an hour kind of thing a long time ago, and I thought that gave it extra wear. All right, decelerate. When you get the rope to the launch line, you do it once or however many it takes to kind of judge where you want the hardware to be lying, and so you just take your foot off the throttle and just let it kind of coast to that more or less stopping point, so that the slowdown deceleration is slow. If anything goes wrong, stomp on a brake and whatever, you know, do whatever. But under normal circumstances, you want to slow the drum down because it has some inertia, and it's going to keep turning if you stop suddenly. With this rope, it doesn't backlash like the steel, but boy, it would be a disaster if you did that with a steel. The rope is, and with Roman stuff, it's not very critical, but you can spool it up, loosen little coils on the drum kind of thing. You want to avoid that by a slow deceleration. If you're halfway down, any position down the runway, you can start back whenever you want to. If the glider's coming in and looks like you're going to be worried about being in his way, landing, then take the vehicle. In our case, it would be, hopefully we'll have a west wind, it'll be to the right or the south side of the runway. Just go, start turning at a right angle, or even a little back toward the winch, over to the side of the runway. Stop and wait, just so you're comfortable that nothing's wrong. Then when you pick up again, turn around, do a 180 or more with the vehicle, come back out to the middle of the runway, to the drag line, get on the drag line. Now you have this loop right here. That will usually come out very cleanly. You want to avoid bows. Now what most people tend to do, if we're coming from him, from the winch, glider gets in the way. A lot of times, okay, they casually start drifting off to the side. So now you got this gentle radius over here. And, okay, they do whatever they're doing, and if they use the same concept, they casually come back, so now you got this bow. Could be pretty good size. It doesn't take much. That rope actually cuts itself a groove. So now you got this rope feeding through this temporary groove you've got over here, which is a lot of extra wear. Or if there happens to be an extra rock there, it's a little harder. There's a while that rope is slicing and rubbing friction-wise against that rock. We've had trouble with that with weeds. You get some strong weeds. With steel cables, we didn't worry too much about. We just saw the weed off it before long, kind of thing. But the rope won't do it, but you'll be damaging the rope, either friction-wise or abrasion. So getting out of the way, sharp 90 degrees or even back to the winch a little bit so that when you make your 180 back again, you've got this loop in one spot, and it forces the rope to come back on the drag track back to the winch. Easiest, cleanest, and quickest. Okay? Anything goes wrong, sure. Lock it up, stop, do whatever you have to keep from getting in trouble. You know, worry about anything else afterwards. And then, of course, again, as a visual, if something goes wrong, get over to the side. Well, actually, it would be way over here, you know, that type of a retrieve truck rope driver. Brush. Almost always have a little bit of a crosswind, very rarely have it straight down the runway. When we do the deliberate simulations kind of thing, winch driver, when the glider comes off the winch driver is automatically stops just as quick as he can. Glider's got to do what he's got to do. Well, there's a bit of a crosswind. Yeah, it's going to carry 2,000 feet of rope or whatever it happens to be. It's going to drift off the runway, and we got brush there that, you know, it's like, I don't know, it's like hacksaw blades. So what we do is, if there isn't very much in the brush, we try to lift it and pull it out to the runway, which is the safest, we think. If there's too much of it and you're by yourself kind of thing, then unhook all the hardware in the parachute, communicate with the winch radio-wise, since that's what we're relying on, and he'll slowly start pulling the rope through the brush all the way back and hope that it doesn't snag on the, you know, minimum abrasion on the rope. There's not much more you can do about it, you know. If there's a bunch of us down there and free, like, well, okay, boy, 3 or 4 guys can work a lot of rope out of the brush and bring it out onto the runway kind of thing and then take it out, which is first choice if we can do it. But then the hardware's off, pull it through the brush.
You unhook where the parachute goes into the tow rope.
Yeah, you don't even want the carabiner on, probably on the tow rope, although it probably wouldn't hurt, but generally, you know, this is going back to the winch, you know, you unhook it kind of thing, and this is going through the brush back to the winch to where you get it back on the runway. Now that's rope truck driver pretty much, and you, again, I'm counting on you as part of the clinic as we rotate through these stages. That one of you is PIC, one of you is line person, one of you is rope retrieval, one of you sitting down or standing down at the winch trying to see how that works. So that's 4 people, 4 stations that I'd like to get you to rotate through.
The biggest mistakes I made when I was running the rope at first was I accelerated too fast.
You started too fast.
And that would cause backlash on the reel.
Yeah. Very gentle acceleration, very gentle deceleration. Any kind of emergency, do whatever you have to deal with it. We'll deal with everything, anything that might go wrong afterwards. Okay. Any other comments on that, by the way?
Right.
for us. A lot of this is site-specific, I would say, but then in general, you need a routine, and so, but you got takeoff preparations, I call it, so item paragraph 8. Wind direction, obviously in this case, you want to go upwind. The higher the in my opinion, the higher the performance of the glider, the more critical it is that you're upwind. You take a glass glider, pretty good performance, and you're in dead air or a little bit of tailwind, boy, personally I would say don't go unless you really know what the environment is and you got lots of runway or whatever that case is, because it does make a substantial difference, and the higher the performance of the glider, the more critical it is to parameters. You take something like a Schweitzer or utility, I call utility gliders, you know, with a wing about this thick kind of thing, and you know, they definitely are less sensitive to that kind of stuff. So the higher, again, my generality is higher the performance, you want as much in your favor upwind and some wind. If it's calm, avoid going, unless you know exactly, you know, over experience what you guys can do. Okay, wind direction, upwind. Now, Roman's diesel winches, you can go downwind fairly well to some degree. We were doing 8-10 mile an hour downwind with the diesel, with about 4,000 feet that we were working on the rope, and definitely functional. You get the automotive winches, the cannibalized automotive winches, even our club winch, we've done slight downwind with it, and it makes a big difference, and it's not necessarily in your favor. But again, if you got 4,000, 5,000 feet like you guys, well, it probably won't matter much.
9,000 feet.
Mm-hmm. Wind velocity, item B, big difference. Like anything else, you got 30 mile an hour wind, you only need another 6-7 mile an hour and that thing is flying, and that ain't much. If you can sit on the launch line and hold the wings level, you're going to get a really good launch. Meaning good altitude, nice positive climb and all that kind of thing. So know that, well, whatever the wind's blowing is going to change your launch. So. Density altitude, in our case it makes an obvious difference. And I'm going to assume everybody's very familiar with density altitude. I can remember back before I would think about it much, and we could say, boy, work your butt off, or my butt off, and damn, I couldn't get over 800 feet. What the hell's going on? I can't get this going, you know. Pretty soon somebody says something or it sinks in. Oh yeah, it's only 100 degrees and you know, we're 3,000 feet and wow, density altitude, duh, you know, it makes a difference. Okay, item D, which I have a lot of, and let me make sure, I'm not sure, we'll double check what you got in yours. Okay. Cable brake options. I personally invented this kind of thing that on every launch you gotta really focus on 3 things. And I call them the 3 A's. Every launch. Airspeed, altitude, attitude, or airspeed, attitude, but airspeed's always first. No matter what's going on, whatever training you got to have airspeed. You're going to probably come close to dying or not. You know, you got to keep that thing flying. Airspeed is, I just can't emphasize that enough. Get that airspeed. Keep the airspeed. Now, then, right along next to that, second, you got to know what your altitude is. You got to know what, you know, be aware of what attitude you're in when something goes wrong. And you've only got a moment to know and to be geared for it. And that's the hard part I hate about the ground launch training, is that guys aren't used to it or whatever, that we sort of hopefully do automatically, you know, if you're new to it kind of thing, it's like, oh my God, what happened, you know, and boy, it's getting almost too late. So on every launch, and hopefully I don't forget it and I get lazy or whatever, just to ask you or remind you, what do you got to focus on the launch? 3 A's. Airspeed's first. You got to watch that airspeed, maintain that all the way through the launch. There are areas on the launch that it's less critical. But no matter what, can't I say it enough? Airspeed, then attitude, which is you got to recover from, and you can only do that with good airspeed. And then altitude, where you're going to go, what you're going to do with it, which is a combination of where you are on the runway, which you might not have to pay too much attention, how much headwind you've got, and whatever, of course, the altitude is what you're going to do with it. And I'll try to emphasize that more as we go. Any questions from that? Again, we really want to emphasize those 3 things to focus on every launch. Okay? AD, E, direction of turn versus wind direction. I can't ask you which direction you should probably turn if you got a crosswind, because I still got it written on here. So if you have an emergency rope break and you're doing a recovery, I've got it written, recover on the downwind side. Now, I'll turn that around and ask you guys why. Can you appreciate why, if you on the ground launch, you've got a crosswind, why do you want to work off the downwind side?
Less turn into the wind.
Actually, what do you mean by recover on the downwind side?
If you have a rope break like an air tow and you have a rope break,
Yeah.
you get trained as to which way you should turn
Yeah.
for your recovery,
Is
back
turning
to the runway.
towards the wind.
'Cause
Depends on what you're doing.
You're usually already downwind.
Yeah. And they train us into the wind so you don't get blown away from the runway, land in a tree or whatnot.
Yeah, you turn into the wind. But you're being blown downwind, is what you're saying. If there is a
Well,
crosswind.
there's a caveat to it. If you're going to make a 180, you turn into the wind. If you plan on landing into the wind, you always turn
If you're gonna
downwind.
go, if you're gonna go to 3, yeah,
If you're on an
come back
arrow tow,
around.
if you plan on landing into the wind, you're going to turn downwind. If you're planning on landing downwind, you turn upwind. That's the arrow tow rule.
Yeah.
Well, okay, now I'll throw in there, I'm not aware of any published articles that tells you which way to do it on a ground launch, other than to recover on a break.
He's
For a
talking about ground launch.
For a ground launch.
Oh.
Here, let me go through the whole drill here. You guys have kind of thought about it. Okay, you were kind of mentioning, you seem to be reacting to what most of us have done. If, in our case, we often get a little southwest here. Again, I guess backwards on your map kind of thing. So we usually get frequently a bit of a southwest, wherever the site is doesn't matter. Just the idea that we got. Border fences, in our case, down here. All right, now, what I was asking you is, you are taking off with the glider, upwind, winch is sitting over here. Now, as a comparison, if you're doing an air tow, backing up a step, if you're doing an air tow, of course, we're going upwind. And what did you say the tradition is?
If you're doing a downwind landing, you turn into the wind. If you plan on landing downwind. If you plan on landing into the wind, you turn downwind. And I can show you really quickly why.
Anybody want to argue with him well, before
No.
before he uses his stuff?
So 200 feet, we're gonna turn,
Because on the
Into the
downwind, it blows you back over the
Right.
runway.
yes.
Yep.
I mean, if you're landing into the wind, you don't have to turn as far to get back into the wind.
Right.
And that's why, that's the aero tow convention.
Well, I'll only argue with you in one point.
Has nothing to do with ground launch.
If you have that benchmark 200 feet, it's not where you just drew it,
Well, I'm not saying it is.
okay? Where is it traditionally at on an airport, which is what most people get trained with and get used to. That
It's
I'm gonna
way
break
off to the end of
I want
the-
to break
off.
this habit kind of thing, right, before we go too far. Where are you, Paul, you're not getting, you're trying to keep you awake here. Where are you usually at? If you have if you're going to do a rope break return and an air tow, where in relationship to the runway here, taking off this way, where are you probably going to be at, say, 200 feet?
Lengthwise down the runway?
Where you're standing.
Yeah.
Okay?
Probably by, almost to the end of the other runway, where I make my turn into the wind and right back down the runway.
Okay, so again,
Often.
air tow takeoff,
You're gonna be out there.
Yeah.
Yeah.
training is, even though you might be drifting a little bit this way, whatever it happens to be, depending on the tow plane pilot,
So,
your recovery is out here, is probably going to be in this direction. Agreed?
Mhm.
Doesn't work for a ground launch.
Because you're down there.
I was just, that's what, yeah, hit me. I was just thinking about that.
You're still over the approach into the runway.
Yep, 200 feet, 300 feet down the runway, maybe.
Yeah.
Okay, so if you get a rope break at that magic 200 feet, which, oh, I've had that happen once when we were further down there. Oh, God, did that scare me. You've only got 250 feet, damn it, don't waste any time, get that sucker around now, you know? You're doing a 360.
Mhm.
Probably. That's not what I want to do. Okay? So first of all, back to what I started with. Wind is from this direction, which way should you probably turn? All right, on a ground launch, you want to do your recovery from the downwind side of the runway. Now
It
here's
doesn't
why.
make a lot of sense to me.
Does or does
for
not?
For one reason, I don't know where on that runway I'm gonna be at 200 versus 300 feet. And that will enter into the equation.
You're going to be
You
basically
get
in
a
the
pretty
same
good
place.
idea. I mean, it's not, yeah.
Well, first of all, before I get to your part, I'm right now working on the idea, if you're going to do a recovery from some emergency or real emergency, do you do it going upwind or downwind? That's what I'm working on right now before I get to yours.
Okay,
It would, from your position, it makes no sense to go upwind.
Straight
Because if you went into the wind from the approach into the runway, you're just going to make yourself in a bad position. But if you go downwind, you're in a much better position, no matter which direction you go.
and no matter which altitude?
Pretty much. It'll make sense, I
If I
think, when
can
you.
pretend that's the runway of sorts, well, maybe that won't work for you guys, Sue. Maybe if that's the runway out here kind of thing. If you have a problem and it's low enough to where you're going to, or rather it's in the position to where you can do a 360, whatever the conditions are, you're going to do a 360, which is
into the wind.
this kind of thing and back. Okay? Whatever, before we get to any of that stuff, you do it from the downwind side. The reason I say that, again, if the wind is from Okay. You're on the launch. It breaks. You're going to make this recovery maneuver of 360 degrees. For example, if you, just picking arbitrarily 200 feet, which I really wouldn't do. If you got 200 feet and you're going to do this 360 to get back onto the runway kind of thing, winds from that direction. If you go and say use 50 feet to get away from, because remember, you got to remember, you're on top of the runway when this happens. So you use up 50 feet. Okay? Now you continue the turn to make this 360 to return back to the runway. Now you're going downwind. Now you're making the turn back downwind back onto the runway, which 50 feet isn't whatever you used up. Whatever, I don't know what it is. Now my comparison is now, winds from him. Now, same altitude, just academically 200 feet. And we're going to use that same 50 feet. We turn downwind 50 feet. Now we're going downwind. Now we've got some separation from the center line. How much? More than on that side. Now you can make the continuation of the turn. Now you're turning back to the runway upwind. Gives you more time, comfort, whatever, to get back on the runway. All right? But I'm only using the term 200 because that's textbook thing of safety. Everybody says on an air tow, especially that's what you mostly learn, is you get 200 feet. But again, they're talking about a 180.
It only applies to 180.
And upwind, and you're beyond the runway. What you got to remember on a ground launch, all those same altitudes are going to be up here at the launch line.
Can I make this drawing more to scale? Is that all right with everybody? Because
If you're going to land into the wind, it never makes sense to turn into the wind. If you plan on landing into the wind, it never makes sense to turn into the wind.
I've never used that, but that makes sense, yes. I
Because you
understand.
always have to turn more than 360 degrees.
Wind is still from there.
when it's coming here, where will I be at 200 feet on this runway?
250, 300 feet from where you
About a third
started.
of the way down.
Here. I'm at 250 feet. Why don't I land ahead?
Well, that's
that's
where
the
we're
optimum.
going.
At
200
200 feet.
I'm trying to emphasize, 200 is what most people get trained in recognizing is
Okay.
what you do your air tow stuff, because
Yeah.
now I'm going to throw in, since you keep bringing it up and you're stuck on that one yet, that's what I want to get to next. 200, 300 feet, you land straight ahead for us. You kind of get out of that, now I'm trying to break that law of primacy idea that you get trained, tested, 200 feet your magic number because you work with air tows. Not on the ground launch. Up to probably, if there's a little bit of a headwind, especially with our gliders, super spoilers, you could be at 400 feet and still land straight ahead.
What are the characteristics of the glider as far as, I know with the K-21, if you put the spoilers out and you accelerate, you can almost go straight down over the runway. And if you've got that kind of authority with the speed brakes on the spoilers on the trainer we're using, then 200 feet you can probably land straight ahead.
Yeah, well, again, I want to accept and recognize, yeah, you guys have got time and whatever in the other routine. I'm trying to take this step at a time here, so yes, you're right. But I want to get the emphasis in there once again.
The downwind.
Don't get caught up in what you learned, the law of primacy, that 200 feet, and you know. The big difference is, again, air tow 200 feet maybe is here.
Out there.
200 feet for us is over
This
here.
is long
Yeah.
And you want to land on the runway.
winches.
So that means you got to, your advantage is to displace downwind, whatever you're going to do, and get back on the runway.
Yeah, the other interesting thing about it, in thinking about it, is if in here and going downwind as
You
you're
can't.
making this. And you don't quite get far enough around. You still have this axis. Whereas if you come this way and get blown in and can't make it all the way around, you don't have this axis.
I agree.
It just is where you run out of room to be able to get your wings, you know,
I think
at a certain point you want to get your wings level.
Again, my whole point is that if we have an emergency kind of thing on the ground launch, you're gonna have to, you gotta remember that you're down here, not out here. And if, again, now that you brought it out, your first option, if at all possible, is straight ahead. That is your safest option normally. Knowing your glider, knowing that your altimeter, if you first glance at it, is not going to be accurate because it's going to be 150 or some number behind what your actual altitude is. You're going to have your peripheral vision to kind of know that, well, you know, I got enough altitude to take my time to go around, or whoa, I got to go straight. You know, that's the shitty part. You got to get that right. And it's knowing your machine, your site. A place like him, hell, it could be 500 feet pattern altitude practically, and still land straight ahead kind of thing. Now, we don't have that in our site. Not like they do. But, again, generally speaking, when you start the launch, if you're up to about 300 feet and you have a pretty good headwind, first option, go straight ahead. Don't have to fool with anything else. But at that 300, if it's a kind of a low wind, calm day, not much wind, then you're going to be further down the runway. You're going to have less runway maybe in front of you. You've got to be, when you do your recovery, you've got to be able to know, okay, I have enough left or I don't have enough. 300, 250 feet is enough to do a 360. But damn, the anxiety level is high. 300 feet, you're pretty comfortable, or, you know, that's not a big, to us particularly, it's not a big deal to do that 360 on the downwind side to do the recovery and back in again.
I got one quick question. And we do this too. If you're a little skosh on runway, is there anything wrong with doing this?
I would say in our case,
Yeah, that's the,
you're going to be doing turns awfully low.
Okay.
If you've got decent spoilers, like he said, if you go full spoilers like ours, and you push the nose over. In fact, that's a question I haven't asked yet, I haven't forgot about. A little digression, just to take advantage of this comment that you just brought up. He brought it up, so don't interfere. I think you mentioned it, probably. If you are on final and you are too high and you're going to increase your sink rate, what speed would you probably want to use? Like minimum sink, or best L over D, or something else?
In a 21? Or,
I think any of them, anything. You kind of brought it up, I figured you knew.
I know in the 21 you just
Well-
accelerate up to 90.
Well, yeah, I know you mentioned it, but that's why I say don't answer yet. Let these guys, they haven't said anything with it yet. You're
Depends on the
high.
glider.
You got the spoilers out. You want to increase your sink rate. The steeper your descent rate is, because nobody mentioned it.
Drag.
Your parasitic drag is the maximum at red line or near red line versus minimum sink. So if you got spoilers out and it still ain't enough, put the nose down. If you get the chance to run it to red line, you're going to burn up that energy and your altitude the quickest. And of course, you've got to do your round out, which you compensate for or whatever. And if you got full, like especially in ours, if you got full spoilers out, or the Grove especially, that's a good one for it. Boy, as soon as you kind of round out or flatten out, you're going to be decelerating really rapidly, noticeably, at full spoilers. So my point was just that you threw it out here. I want to emphasize it again. If you're high and you've got spoilers out and you need to increase your sink rate to get it down, you don't slow down. You go as fast as you can tolerate or get closest to the red line, and you get the greatest amount of parasitic drag. I can be, like you said,
And the other thing is, your fear of floating, don't close the spoilers too much.
full spoilers, high speed, more parasitic drag, you get a greater sink rate overall than going to low speed.
Could you also slip it down?
Not on some of these medium performance, high performance gliders. Slips don't necessarily work very well on some of them, you know.
Fourth A for you.
You need to make that decision. Are you going to turn upwind or downwind? And my whole point was, law of primacy maybe, all air tow people, when you got a rope break, usually it's always turn upwind, because you're going to land downwind, and you want to have minimum ground track back to the center line of the runway, but you're out here. And I want to really make the point that when you have this happen with a ground launch, you're already over the runway. You've got to displace somehow to get yourself back to the runway. I think is my main emphasis. I can't push that enough at the moment.
So react opposite as you would on an aerotow rope.
Yes. If you can avoid it, yes. You want to avoid, that's one of the options that's in the books, is that you could have the option of doing a 180 and returning back to the runway. But that's, to me, now that's the last most unsafe option you've got. Plus, if you are starting here and you're trying to do a 180, you got nothing left.
You won't make it.
You got to remember that what all the training has been before has been air tow, and they're trying to erase that at the moment and get you in the mindset. Your first best option, airspeed, of course, attitude and altitude. Attitude is unique. According, I like to quote Alistair, as soon as that rope breaks, you're in pattern. You want pattern speed immediately. That's your life. And I've seen delays, and oh, Jesus. It's trying to recover from a stall at 250 feet, you know, or a spin entry. Shit, you know. So anything goes wrong, first thing is you put that nose down and you get flying speed. And Alistair will push at you. He wants you, don't do anything until you look at the airspeed. Point to it, maybe maybe have you ask you, what's pattern speed or whatever, you know, here. So that hopefully you're not thinking too much about it. That's what you want. Now you decide, assess where you're going. Straight ahead if you can is your first choice. Second choice, if you're firing it down or the altitude is there, 360 and 300 feet is pretty comfortable. Maybe either way depending on the headwind. Whether you make a 360, landing down here, or if you got a good headwind, 300, you can go straight ahead. If you need, this got me to the point, is if you need a higher sink rate and you got full spoilers, do you slow down or speed up? Speed up. Put that sucker down to the ground, flatten out, and boy, you know, you got the two things. Spoilers are out for drag once you round out, parasitic drag to help you increase the sink rate. You're thinking hard, huh?
Yeah. I'll do it.
Well, I hope so.
I
I don't want to get hurt again. Yeah.
The other point I make to my students is when you do a 360, you pretty much land where you are.
Yeah, and that's simply because you question whether you have enough runway left.
Because if you're making the 360, you're going to land pretty much where you started that 360. Not very far beyond it.
very likely.
And if you're not gonna make the end of the runway, you're still gonna make the runway if you do it right where you are.
Yeah, I don't argue that at all. If you get 300 and above kind of thing, well, that's damn near a full pattern.
Yeah.
I mean, you might not be used to it because of your airtow experience and kind of thing, but when you consider that, my logic is, you want to know your plane to where you're far enough separation from the center line to where you can make your 30, 45 degree bank turn back to basically the center line without having to make corrections. So, you know you can be pretty close to do that. And that's where we work in that area, that regime. Okay?
Okay.
You had me worried there for a few times there. I was like, oh shit, did I mess that up too much? Okay, so I think that was in the area. Item E, which direction do you turn to recover? Okay, again emphasizing downwind side is your advantage. Okay, 8F, knowing your glider, whatever you are, got to know the red line on the ground launch. What's the V designation for winch launch red line?
No idea.
You know, you got VNE, that other thing, you got VS, and I don't know, all that other stuff I don't know.
Like the
I don't know
president.
what the V number is, but
W.
it's,
Ace and W.
VW. On the plane we're using, somebody said they had the manual, do you remember reading what it is?
it's
Published?
60, isn't it? 60?
Yeah, but it's not published at 60, but that's okay. It's not, the airspeed's not that accurate, but it's published at 59 knots.
Okay, so 59.
That's VW. But whatever it is you're flying, I can only say your manual tells you what you better do. VW. Winch. Now that means, by the way, during the launch, nothing else. Okay? Only while you're on the rope, on the winch, VW 59 knots. On ours, we got a big ugly white triangle on the airspeed. So, again, this is pre-takeoff things. I'm all in paragraph 8. All right, 8G, desired launch speed. Whatever your site is, it's site specific, pretty much. I don't know where I got it from, whether I had help. We call it target speed. During the launch, you have a target speed. Now that's going to vary depending on the quality and manufacturer, you know.
How'd you guys come up with 50 on the Puach?
Okay? All right, so before I go to that, you have pretty much a published stall speed. And probably automatically, what's common stall speed number that you're familiar with since you're newest at it?
I'd say 39 miles per hour, and I would say 136.
39.
39 what?
39 miles an hour.
Miles.
They don't put it in knots, they put it in miles an hour.
It's American made. So you got something in knots in most of the stuff you fly. And if you got higher
41
dollar
knots.
stuff, you know. All right, now, leading question. Does it make any difference when you're doing a ground launch? Is it still going to be 39, you said? If that thing with ground launch?
On your rotation, you can have an accelerated stall.
Yeah, he's sitting over here saying, you're full of shit, man, is what it looks like on his face. You know?
And we always have that one.
All right, so let me rephrase that. Do you think the stall speed is different in some way on a ground launch?
Wings.
Well, I'm working on the question, and is one of my things we just got here, is target speed, right out. You guys are kind of difficult because you got all this other stuff you know. So my question was, does it change the stall speed because you're doing a ground launch?
Yes. Yeah,
Well, your stall speed isn't gonna change, but it will change if you load the wings up, just like you load them up in a turn.
Okay, so what happens to stall speed then?
It goes up with wing loading.
All right, so now we're coming back to around the circle here. You ask what's the target speed, how do you come up with a target? First thing, or next thing I want to emphasize is that, well, okay, you got a published VW, you got a published stall speed, but on a ground launch, your stall speed is higher. What number and what percentage, I can't tell you. But if it's 39 mile an hour, I'd say off the wall 41, 42, I don't know. It's just higher on a ground launch. Just like he was saying, your relative wind, your wing loading, hard bank turn is probably one of the better descriptions I've had, kind of thing. Okay, I got almost break time.
He wants in.
Kevin,
That what I try to use
She,
is you have an upper limit, you have a lower limit. They publish the stall speed for pretty much level flight, not 45 degrees or something of that sort, which means, again, wing loading, higher stall speed. So start at something higher for stall, published. Something, whatever you're flying, go for a target speed approximately in the middle. So when you call the winch, when our case is, just for the drill, I'm going to ask you, okay, winch stand by, winch take up slack, target speed 50. If it's a different glider someplace, you tell them what you want for your target speed. Now, in our case, it's 50 knots. If you start dropping off, winch driver's done something wrong, running out of gas, I don't know, whatever it could be happening, he just misjudges it, wind gradient's not what to expect or something, whatever it is, slower and slower and slower. And again, this is a matter of just a few seconds. You got your target speed, you got your stall speed, which you kind of know is higher than what's published kind of thing. You got a little bit of leeway there. All right, I'll tell you in a minute what to do with that. I'm just saying. The other example is if the winch driver, which is more common, winch driver misjudges it, doesn't know you come up into a gradient, and boy, next thing you know, you're over VW. Well, but again, if it's not much over, you got a little wiggle room between target speed and VW. Okay? Pull it out back of your mind. Now, the next concept with that, VW, which is the limit of the winch speed that you want to use, we work real hard, I do, in the center stage, stage 2 of the launch. Critical. Stage 3 at the top. Pretty close to critical. VW, watch for. Down here at the bottom, what I call stage 1, you're breaking ground, you're accelerating, you've got this gentle climb going. That's not much different in an air tow. Even if you hit VNE down here at the bottom, you're sort of level flight. You're not loading the wings much yet. So down right at the bottom, if you're on a ground launch and you're over sped, it's not very critical. But when you get in stage 2 and you got a steep climb angle, as he said, you don't feel any G loading on it, maximum G's on the wings, you don't want it looking like a pigeon. VW is very critical. When you get to the top, usually you tend to overspeed at the top, just because the coordination happens to work out that way, kind of thing. But again, at the top, you should be leveling off. You're unloading the wings. If you're pushing VW or a little bit, which is 59 knots in our place, you know, you're doing 60, 65, you know, well, but you're kind of unloaded the wings because you're not in stage 2 maximum G loading. Not as critical. You said something else a while ago, and I said, oh yeah, I'm going to come back to that. Now I don't remember what it was.
The rotation and accelerated stall.
Well, yeah, I don't know. Maybe it'll pop up again. Well, I'll get back to my routine. 8G, desired launch speed was how do you decide target speed? Stall, a little higher than published. Definitely an engineering limit, VW, maximum loading kind of thing you want to do. I'm suggesting something in between those two so you got some wiggle room. Either way, a little time to adjust. So now, I'll throw in there, and hopefully I'll have it in other places. If anything goes wrong during the launch, too fast, too slow, it breaks. What is your recovery? What do you think is the recovery routine? Somebody mentioned it a while ago, so don't say anything. You guys that are... Anything goes wrong, you're overspeeding, you're getting way too slow for something is wrong, I don't know, whatever happens. You're getting down in stall speed to say 40 knots roughly for in a
Put the
pitch
nose
climb.
down.
What's got to be your reaction?
Airspeed.
Yeah, the airspeed's will nose down, yeah.
Anything at all goes wrong, flying speed. Remember, I quote Alistair now, really like it. Anything goes wrong, especially a road brake, you're instantly in pattern. And you want pattern speed. On this glider, pattern speed, anybody, you guys with the manuals?
I don't have.
All right, we push for 55 knots. I think it's published as approach speed in the manual at 50 knots. But that's awfully damn sluggish. And you got turbulence or something like it, just doesn't, you know, it's not very crisp. Plus the fact that so many, a law of primacy kind of thing, I want to emphasize that, you get used to, you know, 55 knots is pretty darn common for a lot of planes. Unless you're in the 232 or whatever, something like that, you know. So we use 55, I use 55. Okay? Okay, I got a G.1 there. There was a reminder, stall speed increases on the winch. We already covered that. It's wing loading and relative wind. And I'll try to show you a little example here sooner or later. You announce to the winch operator what your target speed is, for whatever plane it is. And I'll throw in here at this point also, the higher the performance, the glider, the faster you want to go. Okay? Simply because of the wing shape is more sensitive to relative wind, accelerated stall kind of thing, because, you know, all that crap going on. And most of the European gliders can take it.
You're talking about winching speed.
Yeah.
Okay.
Launch speed maybe.
Yeah. On the rope speed.
Yeah.
Okay.
Yep. So again, my point was, if you fly a glass ship, heavy or higher performance or whatever, go fast. And I watched the guy die that way. You know, what really makes the point to me that, you know, what happened to them. Okay. So just generalities. Know your plane, target speed, midpoint, accelerated stall or higher on the winch launch, and you have a definitely engineering VW. Okay. Did that bring up any questions or any new items to argue? It might be more clear. On pre-takeoff preparations. Okay? In our case, as a reminder, the tow hook is offset on the glider to us on the starboard side. So technically, rope could be straight out in front of you and the glider could almost be straight out, and it's probably pretty good, but that won't work on the Grove and some others if the tow hook is in the center, on the center line of the fuselage. So in our case, even to back that up a little bit, when you stage, before you get into it and your weight's on the nose, and hardly it takes 3 guys to lift you, just offset it a little bit to the left, and even where the rope's at, or whatever, when the tension's on it, that'll do you good. Just a few degrees, just long as probably not straight ahead. If the rope is laid off to the side and for some reason the glider ended up over to the opposite side somewhat, some separate, yeah, you could go straight down the runway. That's all I know. Okay, if you're carrying a passenger pre-takeoffs, probably it is more noticeable to you for the passenger CG weight, them sitting up in the front seat. If you got a heavy guy, gal, put him in the back seat. Just tell him, well, whatever you want, that, well, CG wise, you're on the heavy side, maximum, and this thing is 240. Published, I think, 241 pounds, I think it is, if it works out with the conversion. So ballparking 240, Well, if they're close to that 200, 240 range, looking at them, they're kind of heavy. I personally suggest you put them in the back seat. Now, if you keep them in the front seat, which you can, CG is within limits kind of thing, but your launch won't be as nice or comfortable for your altitude. You're just lifting all that extra weight and you're fighting the rope and that weight up there and all, what you don't notice so much on an air tow at that stage of takeoff. But just be aware that if you got a little featherweight up in front, and in our case, at what is it, 51 pounds as minimum, I think, and anything under that ballast, I think if I remember correctly. So if you got somebody at 150 pounds up in front, or 52, yeah, but, well, that's going to affect your takeoff. Your rotation is going to be quicker. It's just going to be a little different, that's all I can tell you. You just be something in your pre-takeoff. Be conscious of what front seat pilot or passenger weight's going to do to your launch. That's all I'm just trying to remind you. If you have a crosswind, back to the crosswinds on takeoff, does it make any difference where you put the glider on the plane for the takeoff launch, the initial roll? It's actually published and it's the same it would be for your air tow. Wow. Nobody's thought about it, or does it make a difference? Okay, the answers, A, B, C. If you're staging the glider with a measurable crosswind, enough to affect you, do you put it on the downwind side, on the center line, or the upwind side of the runway? Start your launch, staging the glider. And then, of course, they say the same thing for an air tow. Works for that.
It's hard to answer when you got a huge runway.
We're blessed with a wide long grass runway too. So.
We launch off center on the upwind side of the runway, cocked, not even on the runway, and do a turning takeoff. So.
Yeah, well, if you don't have that option, and what do they recommend? Okay, textbook test question answer, stage the glider on the downwind side of the runway. course, if you set here, now, put that more in line with the launch, I guess. Why?
You're gonna weather vane into the wind.
You just going.
Put
to
you
the
more
edge
into
of
the wind when you're taking off.
Yeah, just the concept is you get a little more authority sooner than if you're sitting over here.
This rudder control and coming back to the north.
Now you're taking off your roll with a full, maybe theoretically a full crosswind. Although you tend to get some weather vaning that would help bring you back, but it's sort of out of your control. So if you're staging with a crosswind that's enough to bother you or move you kind of thing, then picking the downwind side will give you an advantage, even on an air tow. You get a place like Warner Springs, they have takeoff wedges sitting here. So they put the gliders over here. But their concept is, well, private gliders are usually over on this side, and the commercial gliders are on that side, and a lot of times they got enough power or whatever, they bulldoze through it and whatever else. But if you got a sensitive glider, low profile, high performance kind of thing, your advantage is going to be to stage on the downwind side because you get that control authority sooner, less wing dragging, less chance of ground. I've heard guys say that, boy, you just can't let a wingtip touch with whatever glider it is, Well, all right, you reduce those by taking the downwind side. The same thing on the ground launch. Now, can you do a ground launch without a wing runner? Most of your commercial operations or whatever you do, it's a big deal, you got a wing runner. Do you have to have one?
I would say if the ground is smooth and you don't have obstructions, it's possible.
Don't let him go steal all the glory, what do you think? Do you have to have a wing runner?
Perhaps that's an economic decision. If you want to keep your aircraft in good shape, you'd have a wing runner.
Oh, yeah, okay. But, again,
Well, it sounds to me like what he was saying, it sounds like it's almost so instantaneous. If you get good smooth ground.
The big hazard though is catching a wing on something.
Right, yeah. But other than that, it's possible.
okay, on a ground launch, it's probably a lot safer, comfortable, doable than an air tow. Because you accelerate really quickly, you have minimum time with wing drag. With the exceptions, if you're on a grass strip, and you got grass, and you're
Same.
dragging the wingtip in the grass, the Europeans, whatever, all their grass stuff, the BGA kind of thing, it's like, I don't know if they, it's kind of like they imply nobody does, wing down takeoffs kind of thing. But in our case, if you got a paved runway, you got a tip wheel, or maybe you don't even need a tip wheel, depends on how strong the wind is, you're very capable of doing a wing down takeoff because acceleration is so much quicker than anything else. That wing comes up so much quicker than anything else. It's definitely doable. We've done winch launch operations numerous times with just two people, winch driver and pilot. But it's a sight thing. And what can you get by with? And but you got to know that at least. You don't want to take off wing down, I don't know, some dirt spot out in some dry lake and it's soft and, digging in kind of thing, unless you got lots of room, because it's going to turn you. It doesn't take much to turn it with a wingtip drag on it. So, question was, can you take off without a wing runner? Yes, especially in a site spot like ours with the gravel and the tip wheel.
Yeah, I wanted to talk to you about it when we're on a break, because that's something that we would be interested in possibly doing.
Yeah, if you got lots of room, okay, so all right, does drag for a while and runs you off and some little, more that you like, probably not an issue yet, but there is a limit, of course.
But yeah, we can talk about it when we take a break, because it's site specific for us.
Oh, definitely, and if you got grass,
Well, we have asphalt before the grass, and that's why I want to talk about
but
it.
with the wingtip down?
Yeah,
In
on
the
the,
grass? Or
no,
on the
wingtip on the asphalt, aircraft on the asphalt.
Yeah, so
Lots of asphalt before we even get to the grass.
minimum issue to worry about, simply because there's not much there to drag on that wingtip that's on the ground and that few feet that it could be there.
You have wingtip
Okay.
wheels?
Yeah.
Lost my train of thought. There was one other condition there. I can't remember what it was. I'm gonna come back to it. Oh, yeah. If you're going without a wing runner and you have a crosswind of sorts, does it make any difference which position you are? Up, middle, center, right, left?
I would say you
With
definitely want to be on the downwind
crosswind.
side.
Wing down? Which wing do you put down?
That's what I was just thinking, which wing, depends on which wing. Oh, you're gonna wanna have the,
I'd say downwind position with the upwind going down.
right. Well,
Because as it straightens, it's gonna move faster, which will help help lift it.
Okay,
I was gonna go with the upwind wing down in the upwind position. Cause it's gonna wanna rotate around that downwing.
well, right, so without you struggling with it for a long time, if you just park the glider and you have some amount of crosswind enough to kind of move the glider, what happens every time? Maybe some weather banding, okay, but which wing goes down?
Blowing.
Generally, the downwind wind goes down.
Sure, every time.
Because once it flips over.
So now if you're taking off on a ground launch and you don't have a wing runner, which wing's going to be down whether you want it or not?
Down, wing.
This one's going to be on the ground. Okay? You can't stop it. As far as I'm concerned, you can't get in there quick enough, put this upwind wing down, which is what you hear as a traditional kind of thing, doesn't get underneath of it and all that kind of stuff. You can't get away in time before it flops over on you.
It's always going to be downwind, wing down, right?
Yeah. Now, if you're staging, well, even in this case, if this will work here, she said it's going to weather vane if it's enough of a wind to move you. So which way is it going to weather vane in this case? This looks sort of straight on.
In that case,
That
it'd be
one's
straight up.
good.
It's going to try and weather vane sort of like that?
Dark light is good, but the second one, the
Yeah.
upwind side is gonna be messed
You don't
up.
want to stage on the upwind side, it's not to your advantage. So if you stage to the downwind side and it's enough to flop the wing over and you don't have a wing runner. Okay? So it's going to go over on this wing. Now as you start your takeoff roll, depending on the runway surface, even if it's a good clean surface, what's the glider going to probably do? It's going to have some drag here. So this wing is going to try to hold back.
Lock the door.
So it'll cancel out a little bit of that weather veining. So that's why it's sort of contrary to what you do in air tow kind of thing. I'm looking at ground launching again. If you're going without a wing runner, let it flop over on its own side. Stage it so that your weather veining kind of counteracts your drag on the wingtip, and that's about all you can do. Okay? You accept that? Everybody accepts that?
Do you do anything different on the acceleration?
On the what?
On the acceleration, do you do anything different?
Winch operator, right?
Okay.
No, winch driver
Does the same thing.
getting you off the ground, accelerate you at the comfortable speed, kind of thing, quick as you can. And there's a couple of logics, by the way, that do that. It used to be that site specific. We would have told you pretty hard. I mean, really launch you kind of thing. Well, lots of drag, inertia, broken weak links. We've gotten to where we kind of compromise that and get your acceleration a little stronger. Your ground roll is a little bit longer kind of thing. But basically it's get the speed up as quick as you can, because you know, speed is what speed is number one, airspeed, no matter what you're doing. You guys are making it work. Okay. I'm still on paragraph 8, pre-takeoff preparation. Aim the glider a little bit off to the side, passenger CG, wing down its normal way, you know, and let it fall over. Stage on the downwind side is your advantage. And that's all I can think of, and I got in my notes there. So any questions to that? Okay. I'll throw in here what I learned at a convention. Happened in Canada. They had 2 fatalities, high performance sailplanes. On the launch, snap rolled inverted, went in upside down, or something, ended up upside down.
2 of them?
Too low?
Two different incidents with snap rolls.
Too aggressive pitch up?
Well, I'll qualify this or disclaimer it. I can't say you know, this is just my opinion, and I think what happens to this.
Wing down.
The higher the performance sailplane, the more critical angle of attack or accelerated stall kind of thing happens. Okay? And remember I said, if you're in a higher performance, go fast. If you're doing a launch and it happens to be on the slow side, or the acceleration happens to be on the slow side, what if you get a little turbulence, rolling, tumbling, or maybe a dust devil thermal, one wing kind of thing? Normal pilot reaction is what we always train with it. You keep the wings level. That might be enough to stall one wing. If you're not flying that fast, you know, just go for that fast speed. Pick your target speed on the high side, especially the higher the performance. And again, they're built for higher stuff. Like our Junior, the other one we have out there, VW is 70 knots. The trainer is 59. Whatever it is, go for the high side. Another thing that I think happens on maybe this high performance glider snap roll kind of thing, if you're kind of close to the stall, you might not even have to move the stick particularly, or do that automatic reaction or a little correction kind of thing. All you need is something asymmetric, possibly, to stall one wing. If you hit a little thermal or a little turbulence or whatever. So again, my emphasis is Airspeed, airspeed, airspeed. Gotta keep that airspeed up. Keep it within VW. Best you can do. Okay. Another thing, I guess, I'll throw at you now is where some of that comes from. I think it comes from. Here's my winch. Nice level wind on it, Sam. We have a medium to high performance sailplane. We have what I use for a relative wind example. Now, if you're on an air tow, trundling along, your relative wind is following the road. Any arguments or questions? That's a given, I hope. Okay. So now on a ground launch with a winch, you're starting the launch, that relative wind is straight down the road. Okay? Now, you start a gentle climb, stage 1. You start increasing your altitude a little bit more. Once you get some altitude, you start increasing the climb angle into stage 2, but the relative wind is still trying to follow the road. But the only reason it works is it hopefully doesn't get there. But can you see some appreciation for how the angle of attack is changing as you get higher and the thrust line changes? Okay? Something had come up before. Oh, stall speed's higher?
Right,
Why is the stall speed higher? See, now you got,
you're loading the wing.
yeah, and this relative wind and angle of attack is happening sooner. Okay? Now, my concern for this, what I learned from the example was, we had a guy, actually it was Roman, doing a launch, and the winch driver had misjudged it, the wind was whatever, and he's really slow. Now, you know, at this position, it's going to fly at minimum sink, you know, just above stall kind of thing, you know. 40 knots or whatever, yeah, it's going to come off the ground. But the winch driver stayed at that speed for a long time. Roman's yelling at him. You know, and somebody in the ground said, well, why didn't he's flying, he's got the ground, why didn't he just pull back on a stick and increase the climb angle? Well, critical angle of attack without doing anything else. Okay? Now, I think another scenario is, Roman did this really well. My argument with this came up, if you had that slow launch, and it's enough to break ground, it's enough to be floating up, but let's say nothing happens. Wind speed doesn't, maybe there's something wrong with the wind, I don't know, whatever happened. And you keep getting higher and higher, but the speed hasn't increased. You don't have to change your pitch angle at all. At some point down the launch, you reach critical angle of attack without doing anything except waiting too long. Keeping everything the same, because see what happens to the thrust line and see what happens to your relative wind, and you end up reaching critical angle of attack without you doing anything.
Now you're saying that you're slow and you're maintaining the airspeed?
A slow airspeed, yeah.
Right, you're slow
It's not
and maintaining.
Yeah.
Okay.
Whatever's gone wrong, and what prompted this is somebody on the ground said, well, he had it flying, just increase the angle of attack. That always makes you accelerate. No, it does not necessarily do that, and it probably won't. So I'm saying now, again, airspeed is your life, no matter what you're doing. Number one priority. And that you could be in this circumstance and thinking that, well, okay, I'm just gonna let things alone, but you get to this point, that same airspeed, same pitch angle, the thrust line and the relative wind gives you a stall. You don't do anything, or you didn't do anything. Very critical that you know that. If it's not going well, and the winch driver is not taking care of it to help you kind of thing, what do you do?
Airspeed.
Nose
Airspeed.
down.
Keep that
Release.
puppy flying. Yes.
Now, when you increase your airspeed, you pitch down and all that, is it possible to develop slack in the?
Oh, guaranteed. Yeah, if you're still hooked up, yeah.
Yeah. Okay.
But if you have a tossed hook system in general, that parachute drag when it opens, it click
okay.
and you're off. You're off the rope whether you want it
Okay.
or not. There's no
Okay.
pissing around with it. You're off, you're done.
And at that point, you're really not worried about rope slack. You're more worried about flying.
Yeah.
Right.
Well, there was an incident in Canada, 233. Don't know why, what the training was, what was going on. The guys in the 233, for some reason, either put the nose down or accelerated. And of course, the parachute opened because it unloaded. At some point, winch driver said, "Oh, parachute's open. Oh, I'm going too slow." He put on the power. Parachute accelerated, caught the tail wheel, snap looped him right on the spot, and they lived through it.
Wow.
If you're doing anything with a winch, anything goes wrong, parachute's open, it's done, shut it down, and they're staying ahead of it. They're not.
Step on the brake is what you're saying, right?
Yeah.
Yeah.
Shut her down. Get it out of the way. It's really, really uncomfortable, and I've done this a couple of times before I learned better. I think. Hopefully, I learned better. That we did a premature pushover kind of thing, trying to simulate some emergency. Oh, that is so uncomfortable to see that open parachute just under the wing back here or something. We've had a guy.
Behind you.
We've had a guy at least once or twice do something like that. I don't really know how they ended up doing. They actually went under the parachute. I don't know how he managed to do that. Whether the winch driver kept it going and he dove again, and the rope's going over the top of the wing, but it didn't catch on the spoilers or anything.
Oh, man.
The winch driver shut it down. Really bad. We got a dent on the top of the wing. There's a crack in the gel coat.
So if you stomp on the brake, that usually collapses the chute.
Pretty close to it, yeah. It's not ballooning, yeah, but there is a little time delay there. You can't, it's not instantaneous, but yeah, you want to shut it down, you want to stop it.
And it's got enough brake that if you still left it in gear, it would still stop it, right?
Oh, it's like driving your car. You take your
Yeah.
foot off the throttle and step on the brake. Yeah,
Right.
Romans, I can't say that. Awful guy for personality, but God, he can build. His engineering is just wonderful.
That brake is monstrous.
Oh, yes, you can stop that drum, boy, and hardly even know you've stopped it, But the point is, winch driver, anything goes wrong, parachute's open, you're done, shut it down, stop it. Pilot's got to fly the plane.
Okay.
Pilot's got to keep airspeed.
So the only time you ever want to see an open chute is when he calls release.
Yeah, that's golden.
Any other
But shit
time.
happens.
Yeah, but any other time, so what you're saying is anytime you see a chute and it's on a tow, slam on the brakes.
You're done. Yeah.
Okay.
You don't want to try and save it. You don't want to try and
Right.
catch up with it or anything. It's whatever. It's too far gone. And you as the pilot, hopefully they've done that, and that your concentration is speed. Where am I going? Attitude and altitude, or assess if he wants to throw that in there.
Now typically, when that happens, it falls below the glider without any trouble? Okay.
Well, hopefully without
Yeah, I'm
any
saying most
trouble.
of the time.
But again, I have messed that up enough to where I've had the parachute right out the wingtip kind of thing, or oh boy, don't want to do that kind of practice anymore. Okay. That sort of pre-preps, any other discussion or arguments there, points to make, anything you want? Remember, you guys gotta do this tomorrow.
You got G sub 2, which is altitudes.
Release point.
Yeah,
Okay. Yeah, I got two different things here. Okay. What I'm referring to is your floor altitude, minimum altitude, what you're gonna, know whether you're gonna have to go back or you're going straight ahead. So knowing your plane and like in our case, with this glider, ballparking 300 feet is straight ahead. That's kind of what I was. Now, at one point, I'm not sure, since I don't have this on mine anymore, we tried calling out the altitude to make the PIC aware of what his altitude was. It didn't work because the altimeter's wrong. Okay? And that was just a distraction and an overload for them, and it's like, you're sitting here, and peripheral vision, once in a while you look at. Now what I can tell you is that I put tape marks on the canopy. That if that tape mark is on, looking out there is parallel to the horizon, that's more than that. That's 40, 45 degree climb angle. But you won't have that in most of them unless you put it on your own and that kind of thing. You have to look out at the wings. And then the angle of incidence might be throwing you off like on a grove. So you can't, but if you look at the wings, you kind of get an idea of what it might be getting up there 45. Now, like I say, again, the Europeans go a lot steeper climbs. It's not worth it to me. Just get up there. 800, 1,200 feet, fine. You don't break in something and risking that kind of stuff. But there are guys that, do this in other places, boy, I mean, it's max all the way. It's not for me. Okay, so at any rate, that altitudes, one is knowing your floor, your minimum, being able to get the idea that, okay, boy, I got plenty of time. That broke break, no big deal. Got my speed. Okay, I'm going to come around. Or, oh, I got plenty of room. And that's the shitty spot. I've got to tell you. When it happens, it's ugly and it's very uncomfortable, and you got to do it right. About that quick. Once that stage is over, then you kind of get some time to, okay. And what you don't need to do, with some people, I'll throw in here now from experience we've had, and Alistair will do the same thing. When it breaks, and I want to emphasize when. We get spoiled and complacent about it because it's Romans and it works well, but I'm saying when it breaks, it's going to break. What it does, you 0G pushover, no matter what it is. It broke, boom, 0 Gs, right now. Kind of lost my train of thought. Ding, dementia. Something about, having that next thing of knowing your glider. Like I've seen a guy crash once because, in fact, I've used the term, backing up. What is law of primacy?
The first way you learn it is the way you're going to do it.
Probably.
Yeah.
Sure. So if you fly 233s all the time on a lot of ground launches, you get used to sitting there, you're back in the seat and you're up here like this because of the angle of it. You get in a grove and you do that, you're going to break the rope. So, the law of primacy. You don't want to do that training in here. You got to just know what the launch that glider is going to do, and I can't stop you, other than tell you. You got to know.
I always tell my students, you have to fly the airplane you're flying.
Yep. I mean,
And don't fly a 126 and then get into a Cirrus.
It doesn't matter what you flew yesterday, you have to fly what you're flying today.
yeah, but I'll tell you that, well, you did some launches already, at least you can tell these guys. You know what tunnel vision is? Did you experience any tunnel vision? And here's a DPE that flies all the time kind of thing. And boy, suddenly, you know, you don't see anything, and you might not even be seeing the airspeed, you know, and we're
I don't
gonna,
see nothing.
Well, I flew that one flight with you, and I didn't see the airspeed, I didn't see the altitude. I
Just
did
the
see a little
sky.
bit of the angle of attack, but that was it. I mean, it was launch, we're up, and wow, it's done.
yeah. So I can sit here and hang or fly all you know, forever kind of thing, and I tell you that, well, this is something you gotta work,
Yeah,
you
it
gotta
was-
get through.
You're looking through a straw.
So,
At least there's not the sensation on a winch launch that you get on a carrier. Carrier, you get the profound tunnel vision.
Because of the
But then-
G load.
It stops. And it's like you're no longer flying, you're falling. But you're not. You're flying the 140 knots, but you're no longer accelerating. So you feel this kind of it's a weird feeling until you get used to it.
well, there are many who say this ain't too far from that concept.
Yeah.
And
The
I can,
tunnel vision is-
I'll emphasize, I can sit here and preach this, that.
You just
I've
have to
done
do
those same
it.
stupid mistakes. It's like, it's gonna probably happen. It'll be something like one of the things you're gonna do is call the airspeeds. That you gotta have. Not the altitudes, but the airspeeds, because the winch driver's gonna help you maximize the launch by adjusting the speed, because he doesn't know what the gradient's doing. He doesn't know how much wind there was and stuff, exactly, he's ballparking it kind of thing. But you tell him your target speed, and he's gonna try and do what he can to get as close to your target speed during the launch. Did you have any distractions in remembering to push the mic button and look down here and tell him the speed, you know? And again, you're doing it in about 47, 50 seconds. And you need several of those calls along the way, especially down at the bottom. Stage 1 and then stage 2. It ain't as bad as it sounds, I don't think, and there are advantages to it. And you will become a sharper pilot, I'm sure of that. I don't have any doubts about it. Would you argue that you know, where do you get the chance to maneuver and work that hard, that close and that low than on the ground launching? Every place else it's like, whoa, you got that pattern, whoa, you got the separation, oh, you got that traffic, or whatever it is. We don't have that, it's... Okay. I think I'm finished with paragraph 8. Any comments again before I go to 9? Okay, 9. I'm going to shortcut this somewhat. I found that it's kind of redundant. I went at one point it was like, you know, there's differences, of course, of what your location is. Like we have a single runway, it's only 200 feet wide. You know, it ain't like an aerodrome, it ain't like parallel runways. We go to El Tiro in Tucson, and they got 5 runways, you know, 2 parallels in 2 directions and a diagonal. And you get, boy, it's like, wow, how neat! You guys got all this room, you know. Well, okay, so they're just site specific. I don't know what else I can say there. But at one point, we tried to talk about these different things. If you have parallel runways, you shift over, or you make your turn so that you can land on the other runway, or something like that, you know. You guys are not novices at this. F. You can see I printed that a long time ago, because it was someplace they had it in a different order. First choice when anything goes wrong is airspeed and straight ahead if you can. And up to about 300 feet should do it. Straight ahead. Especially with good spoilers like ours. I saw a guy crash once a grove. Law of primacy. Told him, reminded him, and he gets in the launch at midpoint and you could see him rotating. Honk back on that thing and I'm going, oh, bling! Rope breaks. Over-rotating. Because he's used to this other glider he's flying all the time, which was a LaBelle. Boy, they're good ground launchers. Gets in a grove, heavy tank kind of thing. You don't over-rotate with it. You know, you're very conservative with it. But it works well. Okay. Lots of spoilers on the thing. He afterwards says, oh my God, I looked at the runway and I forgot I'm not flying the LaBelle because the LaBelle, I couldn't have got it down in that time. But the Grove, he'd have come full spot. He had plenty of room to land straight ahead, but no. Law of primacy. He turned. Pretty good headwind. When he turned from the crosswind more or less toward the tailwind, we could just see it drop. That little transition time of what relative wind was here for a short period of time changed here. So he had even less. Crosses the end of the runway, no place to land, except he decided that he certainly didn't want to crash downwind into the rocks and the brush, so he tried to make a turn. About 100 feet, 150, I'm not sure. He gets about 100 and some degrees on the turn kind of thing, and of course it stalls and the spin starts. And what saved him was he was so close to the ground when the spin started it slid off sideways, pranged that wingtip on the ground, bounced it back up, kind of flattened him, and they pancaked in. They probably touched someplace on that wall with the main gear, and the whole thing was stopped probably about where that green chair is. No serious injuries or whatever, but total glider. Law of primacy. He had plenty of room to go. I can't tell you it's not going to happen other than, I kind of can't keep emphasizing, and you saying fly the plane you're in, that's a good one.
The other one is, it's always better to crash straight ahead into the wind at low energy than downwind going fast.
Yep.
Because even if you go off the runway at 10 miles an hour, it's a lot less damage than going downwind at 50.
But I can also emphasize that I know that
Everybody
when
wants
my
to
ass
do.
has been in a bind, oh, why didn't I think of that? It was so obvious, whatever afterwards.
It's a lot easier after the fact.
But, yep, but anyway, this is all, this is ground school. This is the perfect way, I guess. I don't know. Okay. First choice, A, airspeed. Attitude and altitude in either order. He wants to throw another A in there, great. Too many for me, I guess. Straight ahead is your first choice if at all possible. Bending on the glider in the air, headswind. Oftentimes plenty. Your second choice is that 300 feet or someplace range, 360 or some kind of an abbreviated pattern. Even actually in 300 feet, if you were actually do that, you actually have a little bit of a downwind to come back. You know, it's really quite doable. Not as intimidating once you see it done. It's just that most of you don't ever get a chance to try it out, kind of thing, and that you don't. Most guys doing air tows don't experience how far the glider really goes.
Mm-hmm.
Especially when you're down right there, you can see everything really easy. Okay. All right, here's a repetition which you've already gotten, direction of turn versus wind direction. Your advantage is which way to turn on the recovery? Real quick.
Downwind.
Automatic?
Downwind.
Yeah, if at all possible, yep.
Now, just to make thinking easier, do you guys say, the wind is from that side, I'm going to turn this direction? Because when you're up there, it's like, all right, which way is downwind? But if you've already pre-programmed, I'm going to make a right turn if this happens. Is that the way you do it?
If I'm being conscientious and doing it correctly, yes.
Yeah, okay.
You know, it's nice to verbalize it because.
Because that's what I tell my students. I say, if you're going to turn this direction, you tell yourself, I'm going to turn this direction, and not just,
Yep. I agree. And again, verbalizing helps it. Give you a mindset for that, because a lot of times, or at least for me, one of the things I've regretted is I don't think. You know, when I say, I know I'm not the sharpest guy in your hangar kind of, I don't think, I just do something, and boy, a lot of times it was like, oh shit, you know. Okay, again, what's the red line, H for our glider?
59.
Bill, okay. What's it gonna be for your, well, 233. Well, you wouldn't know, I guess, because it's kind of cheating. I think the 233, geez, I can't even remember it now. We used to use that all the time. I think it's 59 mile an hour maybe, huh? Isn't it, a 233 VW?
I'm trying to picture the manual in my head. I think you're right, it's 59, 60, something like that, I think.
Today is
You know, again,
60.
all I can tell you is know your machine.
92 is
Ours tomorrow,
so 62.
VW is 59. Target speed is 50. And we've got, what's on the air, what have I got on the airspeed to help you know what VW
Or
is?
you get the diamond.
That ugly triangle or whatever, yeah, okay. Okay, thanks. Well, okay, I've got, I number 1, stall speed. All right, we've already covered that. I've already used a little demo modeling thing, I think helps emphasize that. So any questions on, doubts on stall speed is higher on the ground launch? So speed is your friend no matter what you do. Controlling it is outstanding. All right, I2, communicate, target speed. Okay, we've already done that for your plane. All right, and blank out there, number 3, call out your altitudes. Why?
They're inaccurate.
Yeah, and you got enough to do. That was just a distraction.
Yes, this.
All right. All right, number 10. Takeoff checklist. Greg, I guess. What is your takeoff checklist?
It's, when I'm flying, like it's basically this one, basic one, but for my glider specifically, like my LaBelle and my HP-18, I've got a specific checklist that I use. So, but if I'm flying like the commercial operations gliders, this is the one AABBC, yeah.
Yeah, and my only point is you need one.
Yeah.
And in our case, would you please, before we do each takeoff, is go ahead and verbalize it. You know, okay, altimeter, and we both agree, you know, attitude, well, one guy here likes it, it's, you know, trim position. Trim on this is a little green knob slider on the sidewall. And there is a tape mark or whatever, so the knob of the trim, approximately on that tape, we're all pretty much standard weights here, so that's ballpark, close to neutral. Okay. And of course the ballast, there's screw-in ballast. By the way, I just had an incident. The guys in commercial operation wise, do you ever take lead plates and sit on them?
Mm-hmm.
Yes and no?
Under cushions.
Yeah. Ours are...
Well, I just got the point now, in recent times, I've done this, I've got my own plate with my name on it kind of thing. And somebody brought out the point that all ballast is supposed to be attached. And if you have some kind of an accident, what are you gonna do with this 18-pound sub
gonna say,
under
It's
your
a
butt?
protectile.
Yeah.
And it's like, oh,
The closest we come to that in our operation, we have lead shot bags that we use that have straps on them, and the seat belts go through them
oh,
to hold them down, if
Yeah.
we do that kind of ballast. We also have the slide-in ballast on the 233, and then you have the bolt-in ballast for the rovers, up front.
yep.
That's the closest we get to sitting on. In fact, I wouldn't sit on one.
This is, we have bolt-in ballast, but none of you need it, kind of thing. A lot of times what happens with ours is the darn bolt holes get rusty and then you can't really get them in. But anyway, there is ballast, and it's against the front seat right underneath your thighs, right on the floor. Two of them, or could be two of them, one on each side, ballast. Okay, belts. Actually, as a joke, would help me tend to remember this at one point. They picked on me and teased me that I had to go A, B, B, B. Altitude, attitude, ballast, belts, and boobs.
And what?
Boobs. I get written up once.
Is that what that plaque is?
Yeah, you saw that,
It's-
yep. Had a gal and her boyfriend. She was well endowed. Strapped them in, 232 in the back seat. Oh, I think I remember. She says, "Oh, that's too tight." Okay, loosen them up or whatever, Short time later, we get a letter that she was claiming that I ruptured one of her silicone boobs. It was leaking or something like that. So I had to write a letter, and whatever, and they came back with it. Just one of those stories, and so what helped me remember the pre-takeoff checklist, I guess,
It's a
You
good
don't
one.
cinch them up so tight or whatever, or maybe the boyfriend was just holding on too tight, we don't know, but
That is a really good one. We need to put
that's one of my other stories. All right, now I got a C thrown in there. Well, no, it's unprinted in yours. No, it is off to the side.
Controls. Yeah,
C,
it's off to the
C,
side.
okay. This is contrary to your air tow. Okay? Air tow, you got your routine. You don't do a control check on the launch line. Generally speaking, that's the rule. Okay? On a ground launch, on part of your pre-takeoff checklist, I'm asking for you to do a complete control cycle. And I don't mean doing it like some folks do.
Yeah.
Yeah, no, I'm asking that you go gently and slow to each stop. Look for that cushion that's back here, or that thigh, each corner, or if there's something else. Okay, so again, controls. Okay, none of this stuff right here in the middle, because the faster you go, the less you feel, and you haven't done full control check. Same thing with the rudder. You guys probably teach on air tows. Boy, you don't wag that rudder. You mentioned it earlier about something. Well, we do. But we're not dealing with a tow plane. And again, steady deep, full travel to the stop. Okay, 2 reasons, same thing. You get that fat foot in the back when your tube is in here, your foot's in this channel. Well, okay, is that your foot? Yeah, oh, okay, or it's something else. The other thing I don't want to do is like some people will do the control check again on the rudder. No, because the rudder cables are usually connected at the bottom. There's usually a counterweight at the top, and you're torquing the rudder. Or it flips it over hard enough and bangs the stop and counterweight. I've seen 2 ribs at the top hinge of the 233 get cracked. Finally, it was like, oh, I think I know what's doing that. Yeah, okay. So we have a big rudder on the Puhats. And so a lot of inertia on it, kind of thing. Whatever glider you are, if there's something dragging, you're gonna feel it a lot easier if you just take it to the stop. You're gonna feel it easier if there's something wrong. Hinges binding dirty. Okay?
If you're in a grove, you can get a line over on the rudder pedals.
I don't know what you mean.
The way they're rigged, you can.
The way it's rigged, you can have a line over, so you won't have full authority on one rudder.
Oh, because it's
You
going,
already have effective rudder in.
Some line looped
And
around.
yeah,
Yeah.
you have, as part of pre-flighting, getting into the airplane, you look forward at your rudders and make sure that the pedals don't have the cable over them.
and that could possibly come from rapid movement, or, yeah, okay. All right, so again, this is what I'm asking you to do. This is our routine at least, okay? Full control, but gently, but Okay, cable, pretty much any time you want, but if you can do it in that stage, there's no big deal. But that would be about the right time. Someplace along in there, you would be calling the winch, probably stand by, and expect a response from them. Winch ready or starting, it's usually what we use. Because a lot of times there's enough delay, we shut it off. And on the turbo diesels and that kind of stuff, it's kind of like the turbo, let it cool down a little bit. You just went from max or high RPM down to shutdown. Well, okay, give it a run time. Starting it up, give it a little build-up time on it, whatever. The gas one is less obvious than that, but at any rate, usually we shut it down. You got 10 minutes or 20 minutes sometimes, okay, there's no sense letting it run all that time. So, winch standby, ready for hookup, whichever one of you is doing the line. And of course, at some point, whatever's comfortable for you, canopy closed and locked. In our case, you can look at the latch and see that it's in the right spot. In some places, it's like this kind of thing, but then I got to look through the fingerprints. And we got dusty ground. Backseat guy, if you want him, if you're up in the front seat and you're PIC, and you know who's in back, and you could say, check the canopy, well, okay, we can go against the rail back here, okay, confirmed, or you look, and you can see where the latch is, that it is engaged. And again, if you're wing runner, safety checker, off to the wing, all the way down the wing, you can see that both the latches are in the same directions, or when you come back from, hookup, or whatever. No set rule on it per se, as long as it gets done. Spoilers, closed and locked. And by the way, don't let me forget that there's a story I can tell you about spoilers on the ground launch. But you do want them closed. Just because it's the efficient thing to do. And then your last thing is all of the story manuals, air emergencies. Would you verbalize it? Try to get that mindset because you want to do it automatically when it happens. Okay, well, we got a little bit of a wind from the wind is so light it doesn't make any difference which way I go. I don't care, just as long as would you verbalize something that looks like what you plan on doing? And okay, usually I don't care. But again, that's important. And then you verbalize your altitudes as a reminder that, yeah, as close as I can get, if I'm 300 feet, I'm probably, with this wind, 300-400 feet I can go straight, or, with this wind, holy cow, 300 feet, maybe I'll have to turn. Don't know, but just kind of verbalize that. Is that yours or mine?
It's yours.
Cheers.
Huh. I didn't even know I had it. Oh, that's, okay. Another stupid solicitor, consumers. God, I get so many.
789-4443, go ahead.
It'll beep them and shut up. See, they don't even answer.
You have 10 old messages. Saturday, 6:41 p.m. Monday.
We flew the same procedures every single day in the jet. Every single takeoff. If I have a problem before this, I'm gonna do this. We
That's-
verbalized every single one of them, even though we did it thousands of times.
That's what I,
Yeah,
Yeah, it was just drilled into
it
us.
certainly
That's the way
does
you do
help,
it.
I believe, yeah.
especially do that when I'm flying a twin. I know what I'm gonna do if the engine quits before rotation, after rotation, gear up, I have a plan. And I try to do the same with the glider too. I know where the wind's coming from. If I have a rope break here, this is what I'm gonna do. I mean, I just take off planning on a problem.
Well, I've got to admit, again, part of my things that it's bothered me in my own routine, I get really complacent a lot of the times. And it's like, I don't know if if I'm just kind of unconsciously, automatically know it or doing it or whatever, but then I got afterwards, I'd say, damn, I didn't plan this or that, or say something, I'm worried about myself and that kind of stuff.
You
Get complacent because it always works this way.
Easy to get complacent.
Yeah.
Okay, I have a sidebar note to myself here is that, and you mentioned it, I think a long time ago, like, you gotta know your slip capability of your glider. And probably ballparking, the higher the performance, the less you're gonna get for slipping, or the more dangerous it is, versus 233 Schweitzers and that Blonic category utility. Okay, you can really get in there and slip it. This one we've got now definitely will slip, but also I have seen it. It scared me because the rudder is quite large, and it's one of those redneck things. Oh, watch this. Here's what you can slip at this thing, I, stepped on the rudder, and I swear, I believe I could bring that thing around 90 degrees. Scared the shit out of me one time because it was like so far over there, it's like one of those dumb things, hey, watch this, I don't know what I can tell you other than that was one of my stupid mistakes, kind of thing. So I watched that because on this glider, you can really push it around, and if you were to do that at 150 feet and stomp on it and it responds so well, now you're sideways to the run, or crossways to the runway, you're in deep trouble. So if you're gonna slip it, enter it nice and steady and deep, and you can get a lot of slip in there and come out of it, kind of deliberately, and okay, it's gonna do it. But, got a lot of theory. Okay. Pre-takeoff checklist. Please plan on trying to verbalize each of those, even if it takes a little extra time. We're going to sit there and wait for you to do it. All right, paragraph 11. Your commands, what you're going to do. First of all, I'm going to say you're not going to do the first launch. You're a passenger. You're an observer. Okay? Listen to the commands that I'm going to give. Hopefully I get to do those for you first. Watch what we're doing, kind of thing, and of course then you're going to take over real soon. And you just check it out, kind of get a... I think you said you've done ground launches before. It's been a while, so probably won't be as much of a surprise for you, but it will be for these guys. If you can kind of think of what your early first launch was or whatever. My routine is I want you to observe that first launch. So, launch commands that we use by radio. Winch, stand by. When you kind of time it to where he could be ready about the same time you're ready. Expect a response from the winch driver. Starting, maybe, or winch ready. A lot of times if he's still running, whatever the conditions are, winch ready. You don't have to answer him back. Okay? Finish the hookup or whatever you're doing. Get to the wing. Kind of check your wing running, because as you guys are PICing now, again, you kind of watch the other guys that are trying to get you going, that they're doing what you, hopefully I'm showing you what to do. You know, you double check them, they're double checking you, I hope. Okay? So see them lay out, you know, we'll get the hook up. By the way, Dean, kind of make sure they're hooking you up on the right hook, correct hook. If somebody, and actually I have cheated with this, I have a word winch comes on the side of the fuselage. Yeah, it's kind of a given, but that's what I've got on ours. But there is two hooks. Okay? Know that the front hook, the air tow hook is under the front pilot. Ground launch is under the back pilot. So you kind of know where that guy's going when you do your setup. Okay, so winch standby, he responds one way or another, ready for hookup whenever you decide to do that. Expect whoever's hooking you up to lay everything out and kind of watch them. See if they walk back and if they're looking down at each connector or maybe checking the wing link, you know, and bringing it back. It's nice if you're a PIC, you've got the canopy closed by then, if it's this kind of weather. And whoever's the line person is coming by, you can see that they've looked inside just to see, well, the canopy closed, the spoiler's closed. Okay, item 3, 11A3, expect parachute rigging laid out straight. I think I got that. Radio call, we've already done that. Expect a response. To initiate the launch, skipping all this stuff with the flags and all, to the right to the radio section is before you call with the radio, you ask for wing and traffic. Either point at the wing person and give him the wing up, or yell at him and, oh, wing and traffic, remind him of the traffic. It's nice to see him stand. We got one or two guys that are new. Boy, they go around in slow motion. Well, they're checking. Can't fault them, I guess, you know. But at any rate, you as PIC and these guys out here on the wing, you know, well, look to see if he's, you know, see if he's done something. If not, you ask him, hey, traffic, is any pattern clear? We don't usually have any traffic, but I'm expecting you guys to go someplace else. Mm-hmm. And so they're trying to get you that routine. And he says, pattern's clear. Well, okay, you can automatic, as a wing person, go ahead and pick up the wing, or, you know, usually it's kind of done together, in our case, you know. Pattern's clear. Winch driver can see it easily enough, because ours is not that long. Once in a while, I've had guys, the PIC, forgets that step or whatever, and then he's saying, take up slack, target 5, and the wing down, you know, and it's like, well, stop the launch, or what, you know. Or sometimes the winch driver will say, wing, what are you doing? What, you know, you can see if he's watching, the wing's not up. You hope he doesn't start pulling. But again, you can take off wing down, in our case. Wouldn't be a big disaster. Okay. So, then it's wing, or rather, take up, I just say take up slack. Target 50. Expect a response from the winch, so you know it. He's going to say taking slack, he might repeat target 50. Or if you haven't said it, a lot of the times, if it's Alistair driving or myself, we'll go ahead and say target 50, because we know we only got the one glider. But if you're in a different place and different gliders, I think it's valuable if you know what the target speed is and get them to say it. Okay, take up slack, target 50. Winch responds, taking slack, target 50. All right, that's the last response you get from the winch. He's going to start taking up slack. You can see the rope moving. Usually it's a little dust going along with it. When the slack is out of the rope and the glider just starts to move, so that you go without slack in it, it's not a water ski. Go, go, go. Because what sometimes happens, you push the talk button and it takes the second or third go for him to get the key, button key, mic keyed or something like that, you know? And then you need to talk loud. Gonna be an issue with you. Gonna have to really make an effort to yell. Because during the launch, you get some wind noise and whatever else is going on. You want that winch driver to hear you. Go, go, go. Boom. Here to the bath, well, on our plane, here to the end of the wall, hallway, or whatever, you should be lifting off. Most times. When you start lifting off, there is a transition time. Everything is getting stabilized. You really can't say much speed-wise, but shortly thereafter, as soon as it seems practical, and you're in that stage 1 gentle climb, you tell him the speed. That's important, because he doesn't know what the wind velocity exactly is. If he's done a bunch of launches, like when I've done, we all do enough of launches, we got a reference speed that we can say, okay, this is what's been working. And it's usually pretty close. But again, the drill is tell him the speed. When you get established and you've broken ground, you're starting to climb. 4 or 5, by the way, not the 45. We try to do single words for the speeds, because that comes through a little more clearly. 4-5, 4-7, 5-0. About that quick, it will be happening. So more than likely, you'll go through 4-5 and 5-0, and you might be 6-0 in this same time span that I just said. But if you're over red line at that stage 1, I call it, right, the loading's minimum is not a big deal if it is an overspeed, but you don't want to let it go when you're in stage 2 and you're putting the load on it. By then, winch should have adjusted, or what do? What would you do if you're still overspeeding? You say pull back?
Pitch forward.
No, as you're going up past the 5-0, but at overspeed, nose down.
Yeah, 60,
I'm loaded.
65.
Yes,
There have
I'm
been
loaded.
times that the guys have made the mistake of what, you're hitting 70. Whoa, 70! Boy, the pitch of the voice goes up, let me tell you. You guys on the ground listen to it. The PIC, you can tell the pitch of his voice, is, or the speed calls get really close together and fast. But again, at stage 1, I call it, that initial acceleration, go through that enough acceleration, and levels out and starts to lift off kind of thing, gets a nose wheel. Go that all stage 1 until you get, the book says 150, 200 feet, width of the runway, gentle, smooth, steady climb. You want to keep the tension on the rope, which helps. You don't want to confuse the winch driver by leveling out, because he can see that and he's going, oh shit. And he has absolutely no idea whether he's going too fast or too slow or whatever. So if you got it under control, initial acceleration, stick about neutral, give or take some guesses to what's in there, get it to break ground. Oh, I don't want you to be hunting for the stick position, because you're not going to be able to find it soon enough. You're either going to over control or under whatever kind of thing. But if you can stick approximately neutral, maybe a little forward, so it does not over rotate, but a little bit forward of center, go forward, control, okay, that's about center, well maybe, not specific kind of thing. The thing is that when you lift off, you know kind of what it's doing. Small correction, that's all it takes. Now, if you don't have it set up already to start with, what you tend to do, come back with it. Some guys, the stick is relaxed up here and there. Oh, okay, we're going to start. And well, I guess we got flying speed, which came up quicker than he expected. He's coming back on the stick and he doesn't know where to go with it, and he's hunting. Yeah, not good. The thing with this, and I believe, the same thing with the Grove, since we used to own one of those, you stick in pretty much your flying position. It will fly when it's ready. You don't have to control the pitch on it if you got kind of neutral stick approximately to it, make small corrections. So those you don't want it to over rotate. You don't want to be doing this at 10 feet in the air kind of thing. Ooh, heaven forbid. You want it just nice, steady, keep tension on it. You can see it, you can feel it. You can feel the acceleration, you can feel this tension on the rope. If something goes wrong, you can feel that surge in it. You just want to keep it smooth and steady. Small pitch changes. Keep the wings level. You got your you can't see anything ahead. Once you break ground and you're starting to get into what I call stage 2, you're looking up there. But you got your peripheral vision. If it doesn't work, you're going to have a lot of trouble with this. But your peripheral vision, you just, as a pilot, you just know that, okay, you can tell what it's doing. Just keep it, crosswind correction, if we get that in there, okay. Easy to say.
Vents. The vents on the side of it, does it have does the airplane have vents?
Oh yeah, well the typical sliders.
Nothing closed, yeah.
I do. And
Just
it's
for
going to be
noise
cool.
of it.
We're going to have cool weather enough anyway. Generally, even if it's a hot day, I close the main part of the slider and I just put the little round scoop out. And that kind of reduces that low frequency drumming kind of thing. And I think I get just as much airflow through there with a little scoop out as the thing is open. That's what I do, at least, on this particular plane, for sure. There is a nose front vent too, but pretty insignificant. Some things like a 233, speaking of vents, rather distracting. In a dirty place like us, when you start to accelerate and you get a face full of dust out of the vent, but it ain't going to happen at your place.
It's funny though, we're still getting dirt from crystal coming out of the vent because our glider came from crystal.
Okay, so commands, radio calls, that's where I was. On the way up, what's the 3 things to focus on that I emphasize at least? Quick, name one.
Airspeed,
Airspeed.
Attitude.
Airspeed,
Try very hard not to forget that in the mindset. Our lives depend on it, let me tell you, for sure. Radio commands. You're telling the winch the speeds, and you've told him the target speed. He's helping you hold the target speed. Now, as you get toward the top of the launch, I call it stage 3 in my routine. The climb doesn't happen the same way near the top. The thrust line is getting closer to steep. I won't say vertical, unless you really, it won't happen with a toast hook anyway. But at any rate, the loading becomes really maximum on the wings because thrust line is, thrust line on the, loading on the wings like this, and thrust line is almost directly at gravity, whatever. So speed is important. If you're overspeeding, this is a danger place. At the top, I call it stage 3. How would you control it? Quick, you haven't talked much yet.
I'm learning.
If you're at the top, near the top,
Release.
you're overspeeding. Well, no, you don't have to do that per se.
Unload.
Unload it, you bet. Level out.
And doesn't that apply
Speed will probably
mostly?
pick up more, but you've reduced the wing loading by leveling out. Instead of being like this.
It applies in stage 2 too. If you're heavy loaded, if you unload, doesn't it do the same thing?
Levels, it takes a wing loading down,
Yeah.
reduces, oh yeah,
So if you're overspeed in stage 2, you still want to unload it.
yes,
Right, okay.
yes, overspeeding any place,
Unload it.
except at stage 1.
where it doesn't
That's
really matter.
practically straight and level flight jets, you know, what do you got? 10 degrees of climb, 15 or something like that, yeah, okay, you know, VNE is probably gonna be okay. But stage 2 and stage 3, VW is critical, as far as I'm concerned. No,
So,
it's in the
Unload,
books.
unload.
Yeah.
You
Okay.
can say 7-0.
Yeah, that's often what it sounds like too, yep. And it comes real rapidly, over and over. Okay, so you're at radio calls at the top. You don't have to call anything other than probably not say anything because you're expecting the winch driver to call to you and tell you slowing down. And when we're driving the winch, we go through all of this and we get you up here 60 degrees, 70 degrees, I don't know, it depends on the day and your altitudes, it varies somewhat in the driver kind of thing, but you know, we get you something like this. And then it's from the winch slowing down. And he's been backing off on the power all along. But this is deliberately taking the load off of it pretty much, reducing it substantially. What you do is finish leveling out, knowing that he's going to shut down. You're at the top. What usually happens with this nice toss hook, parachute's going to open because you've unloaded it. If you've done everything correctly, it's going to back release. You're going to hear click. You're off. You don't have to do anything else. If he brings you up, like maybe he misjudges, you got a really high launch and the wind's kind of strong and really working well. If this back releases, it'll be like hitting the bottom of the fuselage with a hammer. Bam! And you kind of feel it flex the fiberglass, you know. We want to avoid that. Sometimes it just catches you kind of thing. The only way you can avoid it is knowing that sort of where you're at. In our case, with a west wind, site specific, an awful lot of that stuff. The overrun, the winch is going to be sitting down here. In our case, if you are watching, and if you look for it, you have the road coming along the airport over here. And about where the threshold line is, there's a paved driveway going to an old broken down ranch right over here. If you can kind of out of your peripheral vision say, yep, I'm pretty much a beam of that paved driveway, 500 feet, 400 feet long kind of thing, it's really obvious. You're at the top. Start unloading it, don't fight it. Wait for him. Oh, doesn't matter, we probably won't do this yet. At any rate, you guys that are flying, when you're at the top, stage 1, stage 2, stage 3, this starts about across the beam from that approximately. When you've done this a few times, during stage 2, you can feel the loads on it and you're climbing. And then as you get near the top and the thrust line of the rope is doing this and you're doing less climbing and you're kind of doing more of this, you can feel that if everything going normally kind of thing. My point is, stop fighting it. Don't add back pressure to try and get a couple of more feet out of it because all you've done is increase the wing loading. When you get up here, just start gently relaxing it because you're not going to gain that much more. You're just waiting to get up this last 20, 30, 40, 50, I don't know how much it is. Reduce the loading. He says power down. You've been relaxing the load on it. You might be accelerating, depending on how close the winch driver is watching. But someplace along in here, he's gonna say power off. You finish a little pushover probably, it's gonna back release on its own. If it doesn't, what you need to do is maybe practice and tell yourself to pull the release to make sure you're off. If you're in a 233 or something else, it's not gonna release, back release. You definitely have to get yourself off. We're kind of complacent because we've got the European gliders and they're built for ground launching, and boy, they're just as slick as a whistle. Okay. What I am using, because trying to keep it to a minimum. We had some people here that took their ground school endorsement from someplace, I think in Florida, and I think they had the launch divided into 5 stages. And God, you can't keep up with that shit, because you have stuff, you only got 47 seconds here. So stage 1 is acceleration, minimum but nice, gentle climb angle, keep the tension on it. Stage 2, gently come back. I don't want to see this kind of thing, a sudden pullback on it. Gently, just start increasing it. Just steady, okay. Look around, check the tapes on there. If you're getting close to the tape, leave it alone. Because we don't need to push it for a max. When you get in the climb, the tape on the canopy is going to something less than horizontal or parallel to the horizon. You're there. Don't fight it. Winch driver tells you, road across from you to tell you to stop fighting. You can feel that it's not climbing like it was. Just keep gently decreasing the back pressure. Let it start relaxing. Unload. Always remember, you don't want to overload the wings. Any questions off of that so far? I mean, it's a lot to do in your second launch, you know. Okay. Oh, radio calls. Oh, in general, just to kind of make you hopefully focus ideas, is that when you get off the launch, generally the winch driver will say good release also, by the way. Slowing down, power off, oh, good release, because we got the parachute and it's okay, just a drill. And then, yeah, it's comfortable for something for you to focus on or to do. You call back and say 1,100 feet or 600, whatever it is, just kind of announce your launch altitude. The only reason I do that, one is a lot of times curiosity to write it down, just to see. It doesn't go anywhere. But then I kind of like it because it obligates you a little bit to know what you got, where you're at, kind of thing. Yeah, you're 1,300 feet, you can say, oh shit, I can go over here and look around a little bit or whatever, you know. You're 600 feet, you know, you verbalize it, well, pattern altitude 600, I'm going to head back over here to the IP kind of thing, you know, that's all. Just one more, to me, a completion. Okay. I'm running out of steam, guys. Questions? We'll go on to the next one, I guess. Okay, and your anticipations as PIC. First thing is, anything going bad, unusual for the launch, too fast, not correcting, too slow, not correcting, wrong angles, I don't care what it is, if it doesn't go right, nose over, keep the speed up, flying speed, I'll say. Maybe not so much nose over, keep the flying speed, pull the release and land straight ahead. Any of you guys off to the side suddenly see something wrong, hopefully you got a radio, you start yelling abort, abort, abort many times until Somebody responds, hopefully. Common weak link locations, 13B. There are three sort of general ideas of where you might expect a rope to break or the weak link to break if it's going to happen. Can you think of one of the places? What would you think? You'd say, oh, it's probably going to, if it's going to happen, it might happen here.
When he first accelerates the winch.
High load, lots of inertia. Sometimes we put a little pebble on it to keep it from rolling downhill, so it's going to roll over that little pebble. Or,
Not hooked up correctly.
well, yeah, that could be, yeah, the maximum loads on it, really testing it then, yeah, that's a good one. Another one is that, not always happening for us, but you get a location, they rotate the glider in one spot,
Get a
and the
hole.
tire gets into a nice little divot. Well, that's a hard pull to come out of that divot, you know. If you see that kind of thing, which could happen at ours because it's a dirt spot right at that end of the road where we push it all the way to the high spot there in the end. You know, okay, take it out of that divot that's kind of there. Maybe put a pebble on it, under it so it doesn't roll on down the slope. It's not a whole lot of slope, but it moves. Okay,
Transition.
that's one likely place. If it's going to break, good place to have it happen. Where's the next one?
When you start,
1 to 2 would be right in front of the, where it meets, where it hooks up with the airplane, right?
No, I meant as far as loads on the rope when you're going to have, you know, probably enough strain on it. The likely place that in good condition it'll often break. It
Rotation.
could break anywhere. But there are probably three places it happens more than any other time.
I was gonna say transition from 1 to 2 when you
First
that
transition,
initial
yeah.
pull.
Sure. Here you're loading it. You're going for maximum climb in stage 2. You want to be gentle. Now, this is why I'm saying when you're coming out of stage 1, your stick is kind of neutral, maybe slightly forward. It'll come off when it's ready. Just keep it going. Smoothly and gently. Keep the tension on it, because that makes a difference. You remind me in a bit. I'll try to tell you why. And then you've got 150, 200 feet or thereabouts, which you can kind of say, oh, this is great. Well, generally for me, it's kind of steady all the way. By the time it just happens. Like, you know, I can't tell you how to do it. It just works for me in that regard. But, as you said, generally in this transition. So what I don't want to see is that, oh, I'm out of stage 1 and I'm going to stage 2. To me, I like to emphasize, you know, if you remember in grade school, our times, you know, that took the little tissue or whatever, wind up, pull, or go snap. So that, I think, nice gentle loading, great, best you can do. Jerk it, pull it up suddenly, that's a sudden load. You really stretch the rope kind of thing. And the glider hasn't had a chance to adjust. You make a sudden pitch change, you've increased the loading quickly, but if you come up gently, you can get the same amount of pitch angle on it, but it's had a chance to, I don't know, it has had a chance to adjust. And the loading doesn't happen the same way. Okay? Third stage, where else might be I mean,
What's the higher transition? As the downward loading is increasing.
can get quite a few breaks there.
Of course, that's probably the least hazard.
Oh, yeah. But now you're looking for rings, you shut down the operation for a while, and you're going, ah, shit, you know.
Because that's where we had the break when we had it, was at the top of climb, and we had to retrieve 1,000 feet of line.
Yeah. Now, again, I only can emphasize, it really can happen anywhere, but frequently those are probably the more common places that it can happen, and you've got a lot of control over. You have no control over this one. That's winch driver and winch speed. You have control over this one, and you have control over that one, because you're not, you're just not climbing like you were. Stop loading it up. Just relax. You'll probably accelerate, and what happens when speed picks up? Aerodynamically, you increase the speed.
Increase drag. Increase the drag.
Yeah, and what's drag is the byproduct of? If you increase the speed, you're probably getting a little more lift, if you let it, even if you've come off some back pressure on this, you start speeding up a little bit, you're probably still getting the same climb as if you were going. Did a lot of loading. So, okay. Open spoilers. Now you guys are all air tow people. You take off with the spoilers open and something uncomfortable is probably happening. Any arguments with that? I mean, you as tow pilots, well, depending on how big the spoilers are,
It's not good.
yeah. Okay, on a ground launch, you're not going to know it. Winch driver's not going to know it. Nobody can see it. And you got full spoilers on. You're climbing, you're going through all of this kind of thing. Maybe you might not have as high an altitude. But you're probably not going to significantly think of it, just open spoilers. Okay? And here's what I think why. Story for this, by the way. I've had a mid-air collision in a Blahnik, Torrey Pines. This was about a 9-foot wingspan. And the asshole zoomed up just as I was coming over the cliff with the guy on the landing. We hear this kicking trash can, boom! Both look over and holy shit, here's plane parts all over. We got half a wing draped over our wing. And it was like, okay, fly the plane! Yeah, well, it was not significant. It didn't really affect us, but we didn't know it until, much afterwards. So when we started to round out to touch down, of course, it changed the airflow on it and this fell off. The other half of it, whatever. And so that's why I have this guy sampled. It did about $3,000 damage on the leading edge of that big wing skin panel on our blank. It dented one of the tip ribs and dented the leading edge, and of course that's a box construction and all that stuff,
Bird strike. Bird strike.
Mm-hmm. Well, now, don't have any on here now, but different spoilers, 33s, or some of the others, Blahniks, they do this kind of thing. Okay? So, this one is more or less drag. Would you agree with that? This gives you drag, of course, but it's really for sure spoiling the lift as well. Okay? So now, if you're doing the launch, full spoilers open, even on a 233, you're in a climb like this, spoilers out here, relative winds coming like this, not exactly like on an air tow flowing across it, doing something. It's kind of like this. Up here, a lot of the ground launch is dynamic loading on the bottom of the wing rather than airflow as much over it, so this might be more in the shadow. But it's not doing much. You go through the launch just fine.
What happens if they come out between 1 and 3?
Nothing.
You don't
even know it.
They don't slam out or anything?
Well, I guess that would depend on the glider, and I haven't had it happen that way. It's usually, my experience has been, somebody, including me, wasn't paying attention, spoilers were left wide open, the launch starts from the beginning, and I've seen it happen to another. I've only seen it twice, actually. But at any rate, that's my theory on it, is that with the relative wind on here, and what you get trained for air tows, full open spoilers on the ground launch, and the power of the winch, nobody knows it. Now, when you get off tow up here, then, okay, you're back in normal effect of what spoilers are used for, and okay, it's going to do something. But not so much during the launch. Actually, one of the nicer stories of it, 233, dry lake out here, not very far away, a small one. Wind was blowing 30 plus kind of thing. Don't know what it was at altitude, obviously higher. And so we're going to do what's called, do you know what kiting is? You know what a kite does, kind of thing. All right, we're doing this with a 233. Get up here, tow car stops, glider doesn't release, and you're just sitting here. You know?
Can you
Well,
let out more rope?
Yeah.
Let out more rope?
Oh yeah, if it's strong enough, yes you could. They call that a double pull or whatever. They've done that in Europe quite a bit, you know. Let them drift backwards, pulling the rope out, and then pull again and get launching, you know, increase the height. But I've never had it that good. But at any rate, 233. As he was taking off, I saw the spoilers open and I'm yelling at him. Of course, nobody can hear it. Kind of thing. Goes to the first whole launch, gets up here at the top, and he's sitting here with the spoilers open, kiting. Finally, I get him on the radio. You know, hey, you think it'll work better with the spoilers closed? Oh shit! You know, you know, never knew it. Okay. I have one more story, but it's my fault, so I can't tell you all my mistakes. Spoilers. I'll pick on Paul since he's got a better chance of maybe knowing this to test stuff. What's angle of incidence?
It's the angle between which the wing is attached to the aircraft due to the longitudinal axis of the aircraft.
Outstanding. You take a 233, I think the angle of incidence is pretty close to zero. You look at a 233 sitting on the ground or whatever, you know, the wing is pretty flat. Okay. So when you do the launches in something like a 233, your climb angle is really translated into the seat, and you're really sitting back here, and it's like this, looking, you know, really looking up, and you can feel and see all of that. Get in a grope, which you guys are going to probably do that, or even ours. It's not too bad. Angle of incidence, I think, on the grope is
It's pretty high.
a little higher up, kind of thing. So, law of primacy. I saw this happen. Flying 233s, he gets in the grope and kind of automatically did what he always do in the 233. So, boy, he tries to make it look like this. Well, here he is, 60 degrees climb angle or whatever. Breaks the rope. I guarantee it, you know. So as PIC and you do these different gliders, I can't tell you how they all work different. You got to kind of work your way into it. Is you can tell if you got a climb established. You can feel it. You can see your peripheral vision. You can maybe increase or decrease it a little bit. But be very aware that you just can't go honking into it like you might with some of these other trainers. You can do between the different blades. Especially those first few launches on your own someplace, you know. Yeah. Okay, so you only get 600 feet on the launch, but you didn't break anything, and you know, kind of know where you're at. Yeah.
You just
That's
get more
enough for a full
practice.
pattern. In our case.
You just get more practice because you didn't go very far.
Yep. But at any rate, angle of incidence really makes a difference between the different planes in what you kind of visually see from the cockpit. You gotta watch for that. Used to be a fair amount of talk, number 14, deep stalls. You should know it automatically, and she should know it automatically. I don't know about the rest of you, because I'm not
What
sure.
was the question?
What is a deep stall?
Where you take it until the nose drops.
Okay? You're old enough to know it. It was a big deal for quite a while, I think. I saw a guy die from it.
So you can't get the nose down.
Pulled so far in that you're with the
You're blanking the tail.
that you're not, that you no longer have elevator authority
And why?
because you're so far into it.
You're shadowing the elevator.
Yep, exactly.
You don't have the authority.
So remember, especially on a ground launch, you know, air tows and all that kind of stuff, you know, your thrust line and your relative wind is always looking pretty much like that. But you get on a ground launch, your thrust line is looking like this, and you got that somewhere. You get the right combination of speed and pitch angle. T-tails was supposed to be the bigger issue. I don't know why they were something that just fit better in there. But you get the right combination there with the thrust relative wind and the elevator
Yeah.
is in the wing shadow.
You're saying T-tails were worse?
Yeah, I don't know why. I mean,
It was
they
a
were in
big
the right
deal on the
position.
early T-tail jets.
Yeah.
Okay, so what happens? You have no elevator. It's not like elevator authority, like you've gone all the way and you got too much CG off or something like. No, this is like it isn't there. It isn't lifting anymore, and you get this. Okay, the guy I saw die with it, which makes me emphasize higher performance glider. It was an LS3. He didn't do.
LS3 with its full flying tail, yeah.
Okay, he didn't do any practice launching when he could have on a bigger runway. He was at Torrey Pines, and I heard he and the winch driver agreed, well, we'll take it a little slower. Okay, I'm at the back of the plane. Back then, before I knew much of what was going on, I watch him go rattling away down the runway in this LS3. Well, Torrey Pines runway drops off through a gully, comes up not quite so high and not a little slope. All right? Rattle, 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 rattle. Nothing's happening. He gets to the drop off. He has enough lift that the ground drops away, but the glider's kind of hanging there yet. He's kind of hanging, and I'm thinking, I'm saying, oh, get off. You know, you can tell when it's a really a bad launch and it's, I mean, the glider just looks like it's mush.
Yeah, wallowing.
Yeah, it's just crappy. I went, oh, shit, Ernie, get off. He didn't. Kind of stayed on it. Well, this is before I figured out that thrust line, speed change not happening. You get to the point relative wind gives you critical angle of attack. Well, he hit deep stall. And I got some pictures of it someplace. At any rate, behind the glider, I can see this rotation coming, very obvious. And I'm thinking, oh, he must have picked up speed enough and he's feeling comfortable to do rotate and go. Just kept coming up, and next thing you know, it back releases because he gets such a high pitch angle. Comes over, he makes about a 3/4 turn and not quite vertical. Speed, if they'd had plenty of speed, this is where I preach it from that, especially that incident. Wouldn't have happened if they had plenty of speed, but I didn't know it back then and what was going on. But I sure try to emphasize it to you now. Your life is dependent upon you maintaining an airspeed. Do something, keep the airspeed. Okay, deep stall. Okay, 15, your sensations on launch. Yep, depending on the winch driver and the conditions, it gives you a good pulse, G loading, acceleration loading, I guess. It's acceleration feel. You know it. It's happening. And we've got hard and fast on here, no question about that. Although, right now with this synthetic rope, it's softened somewhat because the rope does stretch. And that, going back, digressing a little bit about you coming off the ground, keeping a gentle climb going. Now here's what happens. Inertia that you'd said before, high loading, you get the initial start roll. Okay? So now, if you kind of break ground and kind of leave it flat, the rope's going to start shrinking. So you're going to be accelerating. Well, that doesn't last long. Now you're going to slow down. Now you got sagging in the rope. And now you're at a low speed and the tension's not on the rope. So the point is, again, you start the launch, you keep a nice, gentle, just so it's noticeably you're climbing, you keep that tension on there. Now that rope stretch or whatever either stays in it or isn't significant, and you keep the climb going. And you can feel that once you've done it enough. But again, don't let up on it, because if you do, you might as well go ahead and maybe save your problem. Maybe you're not sure. You get off and land straight ahead if you've really screwed that up. But at any rate, the rope stretches. When you come off the divot or the initial inertia drag kind of thing, it's going to kind of slingshot you forward just a little bit, and it'll give you a false sensation or reading. You think it's great, and suddenly, oh, you got the power. Something broke. Maybe, maybe not. Keep steady tension on it. Okay?
As the winch driver, are they accelerating at that point?
Oh yeah.
So he's taking up that slack anyway.
Eventually.
Yeah. Because I did feel that sensation when we lifted off, that it kind of...
Well, no, if I've done it right, you won't feel it, because I keep the tension on it. That's why I say keep a nice gentle climb in it, and that keeps the tension on it. But if you kind of relax or level off a little bit, it doesn't take much to accelerate you. And then, of course, it doesn't go anywhere. You run out of stretch, shrink. And the winch driver can see you flatten out, by the way, and it's really confusing. And then the driver of the winch is like, oh man, something's wrong, don't know what to do. Well, as a winch driver, keep it steady and keep it going. That's all you can do. Okay. 15B, I've mentioned this already, I guess, takeoff roll can be really short. There are times that, as a wing runner, if it's a decent day with a little bit of headwind, you don't have to do anything, just let go of it. It's wonderful, especially if it's a 233. Climb is, okay, again, emphasize, climb is fast, and it does seem unusually steep, and you're low to the ground. You power pilot guys, I don't think there's anything else like it, except maybe Bubba. No, they don't climb anyway, exactly. They're pretty gentle out there.
It's just an acceleration.
Yeah. But in our case, it's, expected. Well, you've done several now, I guess, with us, and whatever, and you, both of you for that matter, like, you got anything you can help them with, is what you said, what your sensation was as far as...
Well, for me, it was one, and I was looking through a straw. But she saw a lot more of them.
Getting the end, getting more C, but other than that, it's like too fast, and then it's nothing. We had a ground school before we took off, so kind of like, oh, this is how to. It's really slowly learning, but right now I'm really more clicking the puzzles, getting together, because it's really fast.
And obviously, aren't you a pretty steep climb angle? It's kind of, wouldn't you say, it's kind of surprising when you're not, first experiencing it? It's like, whoa.
Yeah, it's definitely steeper than what you're used to.
Okay, well, so that's, you gotta expect that, it's normal. Okay, 16. I think I've kind of covered this already. There's my first, second, and third. I tried to make it as simple as I can. The first third is your place to get everything, let everything settle down, and you keep a gentle climb going. The big hazard, according to the British gliding, and now we kind of, we've seen those incidents, is that if you were to have a rope break in stage 3, you gotta have the presence of mind. You actually, you're kind of level in flying speed. You actually don't have to push over for 0G. If you're at 100 feet, 50 feet or something, and that's you don't want to be pushing over or whatever, you're gonna break it. It's simply maintain your flying speed gently straight ahead in stage 1. Very critical. The British Gliding Association and Alistair's brought this up really well, and that they don't even demonstrate it anymore apparently because it's such a tendency for whoever it is, and I've personally experienced it, to go, oh God, broke, 0G, bam, you're on the ground.
They do have a really good video. I don't know if you've seen it, but it's really, and it's online. You can download it and view it. It's really good.
British Gliding Association.
Talks all about exactly what you're talking about.
Okay, well, I've seen it, or better yet, I should say, I've done it, and it happens. So very critical if you're in that stage 1. You don't do the knee-jerk reaction of boom, stick all the way to the stop and 0G, because you're not going to recover. But you've got flying speed, and you don't have a high pitch angle, yeah, okay, just keep it flying. Go down there, land someplace down there. If you have to go all the way to the winch, it don't matter. Stage 2 is where you gain all your altitude. You go for maximum loading. Someplace 200 feet to whatever the top happens to be, depending on the wind. Stage 3, in my case, is at the top where you start easing off on it. You know you're not climbing, so, unload the wings. That's that, to me that's a big deal. There's a reminder of the lower the nose, the release, and all that kind of stuff. Powering down, power off. Okay. 16E, gross weight, heavy front seat. We've already mentioned that. Effects, put them in the back seat if they're kind of chunky. F, make absolutely sure you do not underestimate how much wind direction and velocity affects a ground launch. Not quite like an air tow, where, it's just kind of like flying away. Big deal, but just know that, hey, if the wind's strong, be conservative a little bit. You're going to get plenty of altitude. Don't push it. If it's really weak, know you're not going to get very far. Changes your emergency response. Okay, gradient. Oh, very quick. Chuck, what's gradient?
It's the variance of up and down speeds between two masses of air.
Okay, and Bill, how do we usually see it? How does it affect us? Gradient?
I don't think I'm understanding your question.
Well, if you have a wind gradient, how would it probably affect us?
During a winch launch, as you go through air that is on the ground, in the ground effect, you'll hit an area where the wind is higher, and your airspeed will change very rapidly.
Yep. It's potentially, you could take it to max, or it could do that to you, everything, overload you. Not much you can do about it except, well, okay, airspeed jumped up 15 knots, so suddenly, ooh, what do? You let off the tension, and tell the winch,
It was interesting on that same British Gliding Association research they did. They said up to 20 knots over max winch speed, generally in a modern fiberglass glider, was no jeopardy. You generally wouldn't break anything, but it was more hazardous to release.
More hazardous for what?
To pull the release than to just nose over and try to recover from the overspeed.
Oh, well, all right.
Up to 20 knots is what they found in research, was if you were that high, if you release, you're more likely to crash than if you stayed on and just unloaded.
Yeah, okay, well, I think that goes along with what I was trying to emphasize before, that through here, VW is not a major issue because your thrust line is more along your relative wind. Relative wind's trying to follow the rope, it's not much. But then when you get into this area, the loading certainly makes a difference, and you definitely don't want to be 20 knots over, as far as I'm concerned.
Yeah, I'm
You
not
don't
saying
wanna
they
be-
suggested you do that, but they said that they found that if you just unloaded instead of released, because people would release if they got too fast.
Oh, yeah,
And that was more hazardous than just trying to unload.
yeah, that's kind of that thing of pushing it into the ground, yeah, right at this stage. Yeah, that's true, I agree with you. Hopefully that's the way we do it, you know, we won't have it happen, but yep, I don't know what I can add to that, but unloaded. You're watching the speed, you have as much control over the speed as the winch driver. And you gotta keep it flying. But you know the speed better than the winch driver. Okay, gradient, 17, focus points, there I got them again, just so that maybe you haven't heard it enough. I think it's paramount. You get a mindset for those 3 A's at least. '18, we're calling on the radio, which is the best option, but you could be doing it mechanically. Just like air tows, you could be on tow, back there flopping the wings like a seagull and trying to tell the tow pilot to speed up. They probably never see it, but you get the same thing on same signals on a ground launch. Now, we used to practice that. We had extra, we no longer do that anymore. We used to practice it with the 233 Volatics because they're more utility glider type thing, you could get by with that. You got that nice big fat wing, and if you're flying too, what's the speed signal if you're flying too slow, if you're doing a mechanical speed signal? New to you.
You don't hear anything?
Well, yeah, but that ain't gonna happen this way. If you want them to speed up because you're flying too slow, what signal would you use?
I think it was, were you, fishtail or yaw the rudder?
That's 2 answers. What's your final answer?
Just, yaw. Nothing right.
Bill, you ought to know.
It's yaw.
Supposed to be a big deal for you guys, especially. It's rock the wings. It's like, swim faster. Okay?
If you're
Well-
flying too slow?
Yeah.
You want to
You
go.
want the speed-
You want to go
Right,
faster.
right, yeah.
Now the problem
I'm
is,
thinking backwards right
the higher the performance the glider you get, the more critical, and you know, you get one of these wings that flies almost as well this way as it does that way. Critical angle of attack is a pretty small margin kind of thing, okay? So now, if you're, for example, if you have a high performance wing, something like this, and you want to try and rock the wings because you're already flying too slow. Now, you put this aileron down, it looks more like a dive brake spoiler flap kind of thing. Right?
So it's going to cost.
Really adverse yaw is a super aggressive. And of course you're on this side and you're trying to do this to make it speed up. Okay, well, all right, that accentuates your adverse yaw. But we used to practice that because it was really tough to do. Well, but then we found in many places that, well, what's the worst damn thing that happens? You're already flying too slow. Now you're changing the shape of this wing and you're getting it closer to stalling it. And you got a high performance wing at a critical angle of attack already. And you're adding to the, trying to, you know, no. We don't do it anymore. We could try it if you think of it. Now, yawing it, like he said, what's yawing probably then going to mean?
It's gonna be asking us to slow it down.
Yeah, it's like, no, too fast, slow it down kind of thing. Well, you could be doing that much safer because you're already flying too fast. You're not worried about stalling the wing. But then you'll find when we used to do this, you guys would go like, okay, if you're at the launch line, you can see the rudder go. Oh yeah, but the glider doesn't move because didn't give it a chance to, because you got a kind of a stabilizing rope there, you know. Nothing happens. What you have to do if you were to give that signal is nice, slow, deep. And as he said, you can feel it when you get it right. You're yawing it. And the winch driver can see that yaw. You've only got it looks deliberate. And he's putting on some power, or, you know, slowing it down. It's easy to see. But at any rate, we don't do that practice anymore, but it's still in here. You can do mechanical speed signals. They're almost identical. They are identical to the air tow signals. But speed up from when you're already slow is definitely dangerous. So what do you do instead?
Radio
Radio.
call.
Announce your airspeed. Announce your airspeed.
That's one.
Pick up the radio.
That's one. What's the other thing you should be doing?
Unload it.
Keep it flying. Adjust your pitch or whatever, you know. Control it one way or the other. If you pull them too fast, too steep, unload it. If you ain't going fast enough, gravity's going to get you going. You might be landing straight ahead or something, but that's your options. Or on the radio. A lot of times you go over speed and you let off on it. Hey, 70, 70, whatever, and pretty soon he slows down. Maybe you can finish the climb. 200, 300 feet lower than you would have otherwise. Hard to say exactly, other than that's what happens. Okay, so mechanical speed signals do exist, but we don't do them. Porpoising, what is that? Let's see. I don't know, you got fewer hours, I think you said, in the gliders. What's porpoising?
It's getting longitudinal instability, actually, kind of up and down motion.
Chuck, what'd you experience?
It's called pilot-induced oscillation, and that explains it better than anything.
Usually,
You're
yep.
a little bit out of phase with the airplane.
Yep. But that ain't on what's happening on the winch.
Oh,
Good question.
Hooked on the nose.
Yeah.
You're on the wrong hook.
Well, I can think of it's probably the same thing that you run into when you're on the floats on a float plane on the water. You start porpoising. How you want to correct it is to unload the wing and gain airspeed at the top of it because of the downward motion.
Okay, well, to go back to specifically for us, now, again, it's kind of a loaded question. Trick question, well, it's not a trick question. When would, on ground launch, you get porpoising? Or you can, I mean. What part of the launch do you think it would happen?
number one.
Down low?
I was thinking
Phase
number 3. Yeah.
Oh, you're saying phase 3, you're saying not stage 1?
I was thinking the same, along the same line as he was,
Which?
stage 3.
3?
I'm saying 2 because you're too fast.
Okay. Did you throw in a vote?
I said 1.
He
Oh,
said
yeah,
one.
okay, first one, okay, well, if you're going to get porpoising on a ground launch, you said it, you want to explain, first of all, why would you probably get porpoising?
If you're too fast, you're going to nose over. And then pull back up and nose over, pull back up and nose over.
No, I'll say, I'll throw a no in there to save some time. Where, yeah, why, I guess it was why I asked, right? I forgot what I asked.
Why do you get porpoise?
Why do you get porpoising in
Okay.
stage 2?
All right, the textbook answer kind of thing. You can get porpoising on a ground launch. The porpoising occurs at the top of the launch at the higher speeds.
Down pulling the nose.
But what probably is the primary problem to cause the porpoising? Take a 233, let's say, something like this, you know? Very obvious. Or, oh, maybe any of them. You have a nose hook, 33, you got a chin hook. Or if you got a higher performance sailplane, you got back here that CG hook. If you or somebody is launching, a 233 will launch off the nose hook. A 126 will launch off the nose hook. I'm sure there are others. But what happens is, somebody was kind of mentioning it, that when you get the climb angle, you know, going here, and you got the thrust line going down here, and you're pulling on the nose. It's trying to lower the nose. You're back here with the elevator, trying to make it stay up. This and this will fight each other. The elevator runs out of authority and stalls. Now, when it stalls, this takes over. Boom. Now you picked up some speed. You changed your, you know, I don't know, aerodynamics or whatever. The elevator starts to work again. Boom. Goes back up again. But it only happens at the top of the launch because it's on the CG, or the nose hook, really directly fighting the elevator. Now, if you turn around and put that back here, whoops, thrust line is that way. You can pivot that thing back and forth all over, kind of, you know, because it's on the CG. Not going to get porpoising. So porpoising occurs at a higher speed, usually, at or near the top of the launch, because you're on a nose hook. Okay? If you're in the glider, boy, you know it when you get porpoising. I've seen it to where it throws you against the seat belts, against the canopy or whatever. I mean, it can be violent. That's how I found out about it for sure. They didn't tell me it would happen. I got my, by the way, my ground launch endorsement with I think 4 flights. My 5th flight they sold it me. But boy, was I missing a lot. Okay? And when I did it by myself, of course, in a 126 instead of the 233, nose hook kind of thing, I felt it throw me again, you know, boy, I got off real quick kind of thing. Okay? So, but how do you control it? If it happens, you know, what do you do with it?
Don't pull so hard.
Decrease the angle of the
Yeah, take the load off of it. In our case with the radio, you tell the winch driver, you know, slow down or whatever, but actually the winch driver, if he's trained and he's running a nose hook, you know you have the chance of porpoising, you can see the glider back off. He backs off. That's all you can do. Okay? Test question, porpoising. Happens during the top of the launch, higher speeds, and initiated mostly only by a nose hook. Not going to happen with a CG hook. With a CG hook, you could get the deep stall. And those over. Okay. 20. Crosswind. Tough one for me. I mean, I could do it, but I can't explain it very well. If you have a crosswind, you try to correct for it. The reason, in general, we try to correct for it, it's so the parachute rope recovery is more reasonable, closer to dropping the hardware on the runway. Okay? But if you're doing any crosswind correction, it's going to reduce your climb angle, or your climb altitude. You're just fighting it. Okay? I kind of, I guess, have a half-assed combination of what to do, but there are basically 2 ways to do it. At a place where it's really, you know, we only get 400 feet of climb altitude, we used to do it by banking. Just like a side slip. Keep a bank into it, and okay, a real short launch, it kind of kept us closer to parallel to the runway. But that doesn't seem to work so well when you got a longer climb time and longer rope kind of thing. What I've seen that 29 Palms, I don't know, you guys I think mentioned it, kind of, somebody, I don't know, 29 Palms, well, their club. We had a winch fest there. The wind was so strong between 2 crossing runways. We had a winch on this runway and a winch on that runway, and both of them had the same crosswind. One was left and one was right. Those guys were used to it, and so when I really kind of learned it, I watched a 233 go up crabbing. Shoot, it must have been 30, 40 degrees. Runways like this. Here's 30. Okay. Just rudder over. Keep your climb going, and that's what they would do. For myself, in trying to tell you how to do it, I can't quite do a good job on telling you how to do it. For me, I kind of have a half-ass banked, crabbing crosswind correction for myself. Kind of the way I do it. I keep a little bank in it. I don't know, I just can't break the habit, I guess. And I keep it kind of coordinated on the way up, just like crabbing on any ridge line or something like that.
What happens to the string when you're doing that?
The rope? Oh, the ostrich?
String. Yes.
I don't know.
You'll never
Too many
notice
other things.
it. You'll never notice it.
Too many other things to look at.
Yeah, I would say you're a little closer to being coordinated because it's more like crabbing. You know, kind of a coordinated turn upwind to me kind of thing. If you really like the guys at 29 Palms kind of thing, you know, boy, they're ruddered over like this, and I guess it's pretty coordinated, I would assume. Like I say, mine's pretty shitty. I don't know. I don't see the yaw string. I have no idea what it's doing.
Because the thrust vector is that way and you're this way. It'd be interesting to,
Well, it's chore, it really is. I mean, but I'm saying we need to kind of do it, because if you don't do it, and if it's a noticeable crosswind, oh shit, you're gonna be downwind of the runway out here someplace, you know, kind of like just drifting off, sort of out of control. I don't know.
And-
It just doesn't seem to work, you know.
You'll be
I can't-
comfortable, and everybody on the ground who has to recover the line from the bushes is gonna be swearing at you.
That's part of it, yeah, but at any rate, I don't have a good way to explain that, other than, if you do have a crosswind, and you'll get a call from the winch driver, steer left, or go left, or something like that, you know, bank it a little bit and rudder it, you know, because you know you haven't got enough in there. I don't know, like I say, I just don't have a good way to explain it or to do it. It just, I don't know, I do something and it seems to work for me, and if we have a bit of a crosswind, you gotta do something. My boss.
Look, inside the trip, same as.
Okay,
Now this way, terrible.
crosswind correction. Help out, do something.
Should go
Winch
this way.
driver will call you
We're not gonna do it till we're
probably and say steer left or steer right or whatever it is. Okay, 21. Cable brakes procedures. So, lower the nose, keep the 0 G's if you're in stage 2 or 3.
Oh, they just,
Stage 1 is that critical one, boy. You know, you don't want to shove it over 0 G from not very much of a pitch attitude and not be able to recover because you shoved it into the ground. Bad call situation. I mean, you just got to do it. If you've done it enough times, usually, well, I've done it both ways, by the way. I busted the glider that way, overreacting. Boom, bam, boy, I was on the ground. Hopefully, if you've done it enough times, you kind of, I don't know, you just got a feel for it eventually.
It's almost
Don't know what I
like
can
it's
add.
almost like a bad bounce.
What is?
If you push the nose over at low altitude, you're just going to drop the
Oh,
lift
yeah. You
and drive it into the ground.
Yep. And like I say, I did that once too. I know what happens. So anyway, cable brake procedures, I'm only trying to re-emphasize. In stage 1, it's just kind of like level out a little bit and land straight ahead, you know. And don't be in a hurry like some folks to go full spoilers or something right away, you know. You do your pushover or you level out, you know. Keep it flying for a little. You got the rest of the runway. You can skim along there as long as you got flying speed. And then, okay, take some time to come up on landing. It don't matter if you stop down at the winch. It isn't like you got to get it down in a hurry. You just want to keep it flying and put it down where you want it. Okay. Number 2, visually check the airspeed. That's if you're at stage 2, particularly when you're up at a maximum climb angle. And saw a guy die that way. Whatever he did something wrong. He didn't get it pushed over and sped up. Slick glider, quick input into it, spun it right there on the spot. And I've had it happen to me once. Really scared the crap out of me. Had a Texas gal trained to automatically turn right on release. I said, look at the wings. Look at the wings to get, I wanted her to get an idea of what the climb angle was. She pulled it release, like this. My big mistake was, I said, why'd you do that for? That took too long. We decelerated right away. And of course, her automatic release routine was to go, oh, you made a mess.
Too many hours.
Turn right. So here we were, decelerating like a brick, nose high, obvious right turn, spun us. Less than 300 feet. Got out of that by just by a lucky breath, you know. So the point is, make damn sure you got flying speed. Stage 2 particularly, because when you're like this, it's coming out of 40 to 50 degrees, it's amazing how fast you slow down. I've seen and heard guys talking about they try to take somebody up on a flying day or whatever, make a zoom, try to pull up like, you know, and then say, you got it, you know. Well, that happens so quick, and it's kind of, I haven't been successful at it yet, to show how fast you slow down. It ain't quite the same to me, but at any rate. All I can tell you is you got control when that thing breaks, and you got to maintain flying speed, and that's critical, and you got to know how to do that. Try to visually, item 3, 21A3, try to confirm your altitude. You know, boy, you know, take a look, you know, oh, jeez, I got plenty of altitude. Yeah, I'm 300 feet. Oh, good, you know, okay. No big deal then, to us. Or, I'm going to go straight ahead, because now you can see down the runway. You pushed over and you got your, you know, you're at gliding speed, pattern speed. By the way, remember, as soon as the road breaks, you're in patterns. You're in pattern. Okay. We've got the thing on here, pull and hold or stay clear of the parachute. Well, less of a problem with our case because the toss system is so good it probably is going to come off anyway, you know, on its own. The concept was somebody had a steel cable someplace and had the cable hanging under the glider and of course drug it over some power lines and upset a lot of people. Things like that. I guess that's all I can think of on that. When that cable breaks, and then again you got to choose your pattern. First choice is, guys, real quick, something breaks, what's your first choice, if at all
Airspeed.
possible?
Straight
Straight
ahead.
ahead. That's your safest thing if you can make it work. That's your very best one. It's that bad thing of, well, how high am I? Well, can I get down? You know, but if you take that time to flying speed, oh yeah, well, I got plenty of altitude. By then the altimeter's caught up with you. Maybe you can verify that. If you got 250 or better, yeah, okay. Happens quick, guys. Okay. C, Torrey Pines doesn't exist anymore. Bottom of the page, I've got same thing, tried to divide it in thirds. At the top, kind of relieve the tension, which was really critical with steel cables, but not so much with the rope. All right, any questions? This covers auto tows too. Here's an auto tow hitch. What's left of it? Goes under the trailer ball, kind of locked down. A little bit of Schweitzer hook kind of thing. That was used for some period of time. Gate hinge. Anybody want to? Too excited?
Crude.
I think this is the cat's meow of auto tows. This has been used quite a few times too. Schweitzer gives a little latitude of crosswind, pilot out of position kind of thing. Hooks up just like a Schweitzer on a, you know, tow plane or whatever, but there is one addition here, got a lever. So when you put the hook in here, close this up. So suppose the glider overruns the tow car. You know, it keeps coming up, keeps coming up, keeps coming up, keeps coming up, and,
We got auto release.
okay? Let's, we can play with that a little bit here. Where's that? Oh, okay, oh, there it is over there. Okay, this goes up to the car driver or the observer to, you know, turn around kind of thing without getting out of the car, you know. Go back to the other end. Just kind of wait for him. There, you're standing up. Pretend you're the glider on the tow car. You've overclimbed the launch, you know, you, I don't know, miscommunicated or whatever, and just keep coming up higher. Just keep coming up, all the way up. Keep coming. So now you're flying over the top of the tow car, but you're still pulling on it. Keep pulling.
Keep flying
You're
forward.
overflying, not going up, but you're overflying the tow car.
Don't hit him in the nose.
Pull, 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 oh. You know, that's the concept.
I was trying to avoid having this.
Yeah, okay. Thanks, appreciate it. Okay? So at any rate, I think that's a
Very nice.
very good
Very nice, very nice.
compared to this other thing I showed you. Okay? And the reason also I'm pretty prejudiced to this thing is I made it. Okay, we've used this quite a bit. Now, I bet you it'll take some effort for you to figure out what that is.
For dragging the rope back.
Goes in the receiver, any receiver, you know, car tow or whatever.
It's to drag the rope back.
You do it off of this. Saw a guy break his fingers once though, holding on to the rope outside the window, and it caught on a piece of asphalt and broke his finger. Don't want to do that, I don't think. Of course, so you got 2,000-3,000 foot of rope, 5,000 feet, which we've done. We've gotten 3,000 foot auto tows, by the way. Some airports require a flag. So instead of taping it to your window, you know, got a flagpole sitting here on the checkered flags, you know, kind of like be county conscious.
The flag stand.
Okay. Now, you haven't done any work here yet. Here's a redneck auto tow. Okay. Trailer ball.
You understand I'm a redneck, you know that.
He even has a t-shirt to prove it.
All right, well, obviously, you know, gliders towing with that, the ball's going to stay in that position kind of thing, and the rope's going to stay on there. And if you're towing with this, you got lots of tension on this, and the glider's overflying the car, it's not going to come off. You know, it's coming off now because they relaxed and all that kind of thing. But the more tension you put on there, that's going to stay on there. Okay? Definitely not what you want to go out and practice. Unless you got the trunk open, you got a guy sitting there with a machete. You know, okay, maybe, you know, you got your quick. But then again, we actually have done this. This is site specific. You take and make a loop like this. We've done a bunch of auto tows, a lot with a 200-foot rope. But we only had to go to the cliff. And we only needed we only needed to clear the grass, technically, kind of thing, you know. But at any rate, now if you take a loop really exaggerate the loop like that kind of thing. Now, if you hold that tight or whatever, and you come up with that, it essentially is going to come off. The only time it's probably not going to come off, if the guy's got a crosswind way over here and he's passing up the car, okay, it's a given, that ain't going to work. But if you're overflying, now if you're doing an auto tow like that, you and the glider, your best, my suggestion is, you kind of, whatever you want to do, kind of offset a little bit so that you're sitting here doing this auto tow, which hopefully is across the dry lake, plenty of rope time and that kind of thing. You get yourself in a position where you can see the tow car. And you just sit there, and you just keep waiting and waiting. Pretty soon you see him come up to the berm and he's got to stop, you know, and okay, I'm done, you know, you get off, but you might still get that if you had something else go wrong.
And then you release and drop it all the safe coil right beside it.
5,000 feet of it, which we tried, yeah. We took a brand new rope. You probably know where Coyote Dry Lake is, maybe. It's up by Barstow and Fort Irwin. Yeah, it's about 7-8 miles in one direction, 4 miles or something the other way, or some dang thing like that. And of course we were going crossways and that kind of thing. And so 5,000 feet, 3,000 foot of launch. Okay, truck gets to the end of the lake, releases. Dress with the parachute. So the only way to do it, when you get off the car, you got to follow the rope for a mile. Okay. Well, what we found out in those dry lakes was a lot of garbage in there, old military bases, and what, dang it, there was a piece of steel stuck in that lake someplace in there. And so pulling this back down the launch line, we run the nice brand new rope, dragging it over some steel piece stuck in the lake.
Testing grounds.
Okay. You ever heard of a tossed weak link? Ever seen one, anybody?
Mm-hmm.
This is a tossed weak link. We have 2 of these, and they just don't work for us. But this sleeve or housing you're looking at has inside of it a dog bone, wishbone, a dog bone kind of thing like that. You buy them from Toss. They're color coded for different gross weights. Okay, now that is inside of this little sleeve. This little sleeve is to protect it. There's just a slot on this end where this dog bone is, and the other one is fixed, kind of thing. So at any rate, that's what it is. There's a broken one. Usually break across the middle, kind of thing. And like I say, for us, they just don't work for us, and they're damned expensive.
What failed?
Well, they just keep breaking.
Oh, they break too often.
Yeah, and it's like, oh, why did that break? We couldn't have pulled that hard, you know, whatever. So
Were
we
you using
used-
200%?
Yeah, well, these guys were, like I say, the guys when this was bought, they figured all that stuff out. I wasn't involved with the buying it or and the color codes at that time, kind of thing. I just know that I've been on them and had a break on me too. I don't know. So that's why we live with a chintzy, cheesy little boat rope that we get that's pretty close to the right thing. And the darn thing works for quite a while, and 15 cents a foot or whatever, 10 cents, I don't know much. You can ask Bud what he paid. We just throw the things away on a regular basis, and we use them for a long time. But that is an official tossed weak link, if you guys want to look closer at it.
The reason I asked is they use the same hook at Crystal. And
That,
they can be strong enough that we actually broke the tow system on the tow plane. And the weak link didn't separate. So that's why I was wondering what rating you had on it.
yeah,
Because they go from like 500 pounds up to 3,000.
I don't know what we have.
but you're talking about an air tow, I guess, also.
Well, they were doing slackline practice. And we literally broke the tow system because the weak link didn't separate.
It's some kind of an enclosed system.
Well, this part is just a shield.
Yeah. We have something of
And then they put it inside a tube.
yeah, we have a,
This whole thing goes inside of a
this is
tube.
inside a plastic tube?
It's plastic and metal.
Oh, okay.
The front of it's metal, sometimes the body's plastic.
That's the only thing I've ever seen is those, so I don't know.
Yeah, the whole system, the way it works is the outer shell, which has a metal nose cone, goes into the receiver on the airplane. That trips a switch and shuts off the winder.
Now remember, this is just hung on here because I
Yeah,
just
that's
keep
the
it
extra,
there.
yeah, this is the,
Okay, this is another official tossed ring assembly. Slick as a whistle. We've got two of these, and I don't know why we never use them. Well, I got one of them, like 1.5 of them here kind of thing. But the idea is when you're hooking and unhooking stuff, you know, it's really slick little outfit. Official, expensive, I guess. And right now, I don't know where the other hook is. It might be at the airport, maybe it's been lost by now, because I got half of it here.
Oh, I see, it's got a thin spot.
It's like a chain.
Yeah, it has to be very specific. It's quick and easy. It's quick and easy.
See, now our operation, if you remember kind of thing, we use a pickup truck and we don't actually separate it, you know, all of the hardware and stuff, we bunch it up and throw it in the back of the pickup and then hook it to a weak link. Come on. Hey. Thank you. But there are operations, I suppose, where that could be a big deal if you're unhooking everything all of the time. Our operation, we just don't do that. Okay? God, I hate that. I have the same problem with tools. I just had this thing in my hand. I don't know what it is. Well,
What are you looking
It's
for?
not there on the floor.
oh, I had this homemade fit to give you an idea. Sort
Oh,
of
is
what
it
it's-
laying on the floor
That's
right
what I
here?
thought, it's laying on the floor here.
There's
Oh,
a,
yeah, there it is. I had this brilliant idea that, okay, about the same diameter of what you need for these ropes to feed that through there. Even this is a little bit thick to get in these to, you know, to do this Chinese handcuff thing and feed that through. Romans is just a little bit thinner than that. My brilliant concept was, oh, well, I put these spurs on here and that'll help hold the rope, and all I need to do is put a piece of tape around here and this other shoulder, you know, and I get my own.
How you doing? We're
Don't
still
worry.
in class, I'll call you in about half an hour.
Not at all, because the tape edge on the tape always snags or whatever. So when you see, if you get to work with it on Romans, he's actually got a threaded end that we taper the rope point, put it in a little, screw it down on a spike, and then pretty much work with it. The older the rope gets, the harder it is to splice.
Let's see that. I'm just curious.
Now another thing, if you're doing your splicing, it's highly recommended. I don't have a, here's an idea of what not to do on this piece, is it's very best not to complete your splice with that kind of a rope end. When that's inside the other rope, it's a sharp transition between the rope and whatever the splice kind of thing, and it'll break again probably right there. Never heat cut it. You know, don't melt the ends on it, whatever, because guaranteed that's not going to work. What works best is that what we get by with a lot is we, at the tire of the car or the winch or something, we set this on the tire and saw this off at as sharp of angle as we can, kind of thing, at a taper. Then that'll go in the fid a little bit easier.
This thing is way harder than falling.
You bet. And at any rate, the point then is that when we pull this through to make, well, what I had left of the splice before, generally if we're not in a hurry kind of thing, then we take this end and strip it back, 1.5 inches, 2 inches kind of thing, and frizz it all up and tear or cut off pieces so that the transition is as gentle as you can make it, and that'll be the longest life you're going to get out of the splice. But square, not going to last. Heat cut it or whatever, you know, not going to last. But if you can fray it out,
Yeah, we always taper ours.
makes an obvious difference. Okay. What if you were doing a ground launch and you get a release failure? What do you think you'd do? By the way, this happened to me, I'll say while you're thinking, or try to interrupt your thought pattern, it's happened to me 4 times. On a 233 in the back seat, I got all the cable hooked up there in the front where they, well, of course they yell, "Hey, pull the release," you know, well, the other guy pulled. Had another guy pull firm enough, and it was a knob, and of course, now it comes unthreaded or pulls the thread, and the knob's off. That happened to me once, and it happened to the other guy. And I can't remember what happened to me the other ones. Oh yeah, I know one of them. On a Schweitzer, and I said that on that hook mechanism, if it gets a burr on it, I was on an auto tow, and what an adrenaline spike that is. It's time to get up, and I can't get the release to go. And they're of course still pulling, or I'm going down kind of thing on auto tow. And finally I'm in a panic. And I mentioned it earlier briefly. Shit, when I let go of the stick, of course, boy, it pitched over and unloaded it so quick, you know, and I got off of it. But you can get release failures, and what if none of that stuff works? What would you do?
Do we have a radio?
I was just gonna say,
Yeah, but I'd say
Tell the winch operator to cut the cable.
that's valid. That would be one thing you'd count on, I hope.
Try to fly within the airport property.
What do you mean?
Don't drag it up through the trees and try to stay over the airport.
he's
Oh,
saying
you're
after
still
you
hooked
cut
up though, to the car or the winch. You've got a release failure.
Oh,
You haven't
having,
gotten off.
well, first he's got to cut the cable.
Suppose he doesn't.
Circle down over the winch.
Keep flying the airplane.
Well, okay, but how would you do that? Would you just keep going like this?
Oh, no.
I know a guy who did that.
And circle down over the the tie down.
Back release?
If it's a toast, hopefully, yes, it will. But if you're in one of these Schweitzer things that don't back release,
I can't see anything other than spiraling down over the winch.
that's it.
Spiraling into the wind.
You can, if you're 800 feet in the air, hell, that's a pretty good thermal turn, no problem there kind of thing, and circle the winch.
Just don't do it in the thermal.
Yeah, and wait for somebody to, hopefully that's what they'll do kind of thing. But at any rate, if you have a release failure at the glider for some reason and it ain't coming off and you need time, I think the only thing you can do is, just as you said 3 times there, is, keep a spiral going. I mean, I think the worst scenarios that could happen is you got 800 or 1,200 feet of rope, as you get lower, well, somewhere along the line, I guess you level out and you put it in someplace, hopefully. In theory, I don't know, I haven't done it, and luckily I haven't had to do it. But I think theory-wise, that's...
Have you ever drug a long rope?
Yes, in a grove, I believe it was, it didn't back release, and they had the rope draped over the top of the wing and back to the elevator, and just flew it back because I was afraid if I would release it, the ring would hit something else.
Right, but how much rope were you trailing?
Several hundred feet.
I was wondering, have you ever landed with trailing 1,000 feet of rope?
Not me personally, no. But that's in the textbook stuff. If there's a chance you did not release or can't release and you don't know how much rope it is, yeah, you come in high and make your landing at the far end of the runway, I guarantee you that rope going over a bush at 55 or 60 or 40, whatever it is, that damn rope's going to go, or a fence post is going to go about 3, 4, 5 times just as quick as a flash around that dang post or that, bam, you're going to find out if you got a back release or not. That time, there's where it would make a difference. But if you keep it really high, knowing, or if they can call you on the radio and say, hey, you got a whole bunch of rope, yeah, those are options. I'd say it's pretty rare. And if it's a toss, it's probably going to
I've hooked the fence a lot of times with the tow rope on the tow plane, and you can really feel it.
Yep, but if it doesn't quite break,
Usually we pull the ball off and we rip a piece of fence off.
yep. Well, at any
Never
rate,
done that, but I've-
textbook
I've felt
theory-wise-
the catch sometimes, yeah.
those are options. Hopefully you got time to think of those and then put them to use, and all I can do is say, well, that's what we know that could happen. Okay. Any review or comments? Remember, we're doing auto tow as well as air tow with this endorsement. You could do an auto tow. The very best for an auto tow is a nice, steady, long rope, nice, gentle climb, and you got the length of the rope. Great. If you got a nice dry lake or lots of, you could do it at your place. Okay? What's the difference between a winch and an auto tow? What's happening that's different to the rope that's going to be different?
The auto tow's not getting shorter.
The auto's not going to what?
Not getting
Not
shorter.
Stays the same length throughout the tow.
With the exception of a reverse auto tow.
Over
Oh, yeah.
only at the far end.
Mhm.
Yeah.
Okay.
No?
The rope gets shorter.
Yep. Okay, can you got a picture of it?
No.
What I'm asking is, academically, what's going on, what's the difference between a winch launch and an auto tow as far as what happens to the rope?
Well, rope gets shorter as it goes around the drum.
Sure, it's doing this all the time.
Yeah.
Or an auto tow, which is really slick and nice if you got the
Just
room.
goes up.
You got 2,000 feet of rope out there, you know, you're gonna get 1,800 feet of altitude if you can stay on that long. You can get just about straight over the car or the tow vehicle. Really clean and nice.
Have you ever done any reverse?
Yeah, we have one. Done it at Hucumba quite a bit. And what he's talking about is that you anchor a pulley. We've had two actually over generations of time. Right now, the current one we have is we park a truck, which is heavy enough, and put a swiveling pulley. Now, you have a tow car, of course, you have the tow rope for the glider and launcher in here, the rope comes out here, around the pulley to the tow car. So when the launch takes place, the driver is looking at the glider for half the launch. Then the glider passes over and you can't see anything anymore. And the rope is always, well, what's happening to the rope?
It's getting shorter.
Yeah, just like a winch, okay? So here you are coming along here, the glider's out of sight from the co-driver, or glider from out of touch with each other, and the rope's getting shorter over here, and the glider pilot doesn't know where he's at, position-wise, okay? So a problem that would come into that is if this guy doesn't slow down, he's coming all the way back here, and he's got the end of the rope right here now with the glider trying to rolling and banging on the ground, maybe, you know, kind of thing. So it's a problem. So then what we ended up with, in our case, we put a traffic cone about where we wanted it to be. And now the car driver kind of knew sort of where the glider was, even though he couldn't see him. And so when the truck driver or whatever gets over this, he ends up actually physically stopping. Because if there's any problem with the glider, which happened to us once, you know, he keeps moving, and of course he's still pulling the glider down at 15 miles an hour or whatever. And I can tell you for sure, and it's what happened to the guy that it happened to, and it makes sense, it's extremely, almost impossible to push down enough to overcome that vertical, almost vertical 70 degrees or whatever it is. You can't really follow it at all. So by him stopping there, he knows, that at the glider kind of thing, okay, and the tension's off of it, he can get off if anything went wrong or whatever. So to me, that's the restriction, at least as far as an auto pulley. And then of course there's the European stuff, they use two pulleys or have the speed, kind of thing, tow car and all, get pretty elaborate kind of thing. But we have one of these also. And it's on a box receiver hitch, ball mount type thing, just pin it into some car. But then you need a truck strong enough, heavy enough over here, the glider's not lifting it up. And even on auto tows, by the way, that little Ranger I had there, years ago I've done auto tows with it, because we were desperate kind of thing. And it don't weigh much, and it doesn't take much for the glider to be lifting you back into the pickup. No, of course, traction. So we'd load the back up. We had these tie downs back then, concrete inside tires, and they weigh 150 pounds or whatever it is, So we put several of those in the back of my pickup truck, and okay, we did auto tows for a while because we put the weight in it for the thing. But those are things. Okay. Any questions? Okay. Last page, a little graphy thing. I put this in here at one point, and I had a better sales pitch a long time ago, but I'm using this, I got it listed on the right-hand corner, I think, on yours, trying to identify lift, gravity, thrust, and relative wind critical angle. So my point was, if you look at item 1, a bowling ball or something like that, the top arrow pointing southwest is the thrust line. So if you were to take a bowling ball and pull it on that thrust line, and you can see what gravity is, a typical picture of gravity, you're going to get a relative wind with the arrow touching it in between those two kind of thing, you know. The bowling ball is going to be going forward and dropping with gravity, and there'll be a relative wind in between thrust and gravity. Okay, that's my whole point to showing that this is what I believe happens. Now you go to picture 2 and give it an airfoil. Give it an airfoil, now you got thrust, just like the bowling ball. And you got gravity, just like the bowling ball. But now you've added lift. Okay? So now that brings the relative wind above the thrust line, which I tried to show you before, kind of thing. So now you go someplace down as far as you can go. Drawing 3 is that 233 type, you know, high lift kind of wing, and somewhere the dashed line is to represent, I was just guessing, some angle around there that would be critical angle of attack someplace, approximately. That's all I'm trying to show. You go to item 4 and the wing gets a little more sophisticated, and it's hard to tell in my sketch, but critical angle of attack is becoming a little more shallow, where that wing will stall at a more shallow critical angle, relative wind kind of thing. Then you get to something like a high performance wing again that flies either way, almost equally kind of thing. That critical angle of attack with the dashed line is more horizontal than anything else. Now you put a relative wind into it on a winch launch, which is 6 and 7. High lift wing, critical angle of attack, should be above, got to count on it, is above, the relative wind is above the critical angle, above the dash line. As you slow down and you change your pitch angle or angle of attack, that relative wind is getting closer and closer to the critical angle of attack. And as you get closer and closer to the winch, you at some point will reach critical angle. If you don't have, something doesn't change. Then 8, 9, and 10 was that other compromise wing kind of shape. I'm always saying that when you get to 10 and you're slowing down at the slow speed, boy, get critical angle of attack and that puppy stalls. Or all you got to do is change the shape of the wing by trying to overcome some turbulence, which I think those snap rolls could be. Automatically, you know, put in a little aileron that, I guess you know, or I emphasize, drop the ailerons, changing the same shape of the wing. That's like adding angle, pitch or angle of attack, increasing angle of attack. Get you the critical angle. That wing stalls. One wing. That's all I was trying to show. Any argument or point or something to make a discussion out of it? Okay, you guys must be slow learners, because I'm getting tired.